Welcome everyone to the 8th International Workshop on Genetic Improvements. This is being virtually co-located with ICSE, but we tried very hard to give you the feeling of real conference. In fact, I'm actually having jet lag even though I'm in Korea. That's apparently possible. So welcome everyone. So this is the team behind this year's edition. I'm Shin-Yu. I'm going to open the workshop, and then I'm going to chair Mark's keynote, and then Justyna, Wesley, Wes, and Bobby is part of the team. So we're sort of hoping that we attracted new people into the workshop. So we're going to give you a very brief introduction to genetic improvements. It's not going to be long. So we would probably all agree that programming is hard. And then the whole the GI statement is, while evolving full systems from the scratch has been very difficult to achieve, we can improve existing software using various techniques that we have developed so far in order to do automated programming. So GI is essentially improving existing software by automated search. So we start with the software, and then we do the usual genetic search trick. So we essentially mutate the program in various ways, and that creates a diverse pool of candidate programs. And then out of those, we choose a improved version. This trial and error based on meta-heuristic search is the backbone of GI movement, shall we say. So various types of improvements have been tackled. Some are functional and some target non-functional properties. The functional properties we have been studying includes adding new feature by transplanting from some other existing systems. Functionality improvements and bug repair, automated program repair can be framed as a type of genetic improvements. Whereas if we look at non-functional properties, then various things like execution time, using less memory, using less bandwidth, using less power, or even the size of the program can be targeted to targeted for improvements. So there are a few real-world application examples. When it comes to bug fixing, there are two famous cases. Janus Manager. This is sort of live GI system. The one relevant paper is titled "Fixing Bugs in Your Sleep: How Genetic Improvement Became an Overnight Success." And then the overnight success is obviously a pun. It was a success in its own right, but also Janus works during the night. It will pick up the bugs that reported during the day, and then GI will try to fix them during the night, so that when the developers come into the office in the morning, they will be given with the bug report and also the candidate patch. And then, of course, we are aware of the Facebook success story, finding and fixing software bugs automatically with StatFix and Sapiens. This was one of the more famous industry success from GI. We have seen runtime improvements. So Barracuda is by Bill, who's in the audience, improving CUDA DNA analysis software with genetic programming. This is another very nice case study about reducing energy consumption. So what you are seeing is two pictures, body tracking software's output, but on the left-hand side, you are looking at the result from the original software, and then on the right-hand side, it's a result produced by a variant which uses 1/3 less energy. And then you can sort of see that it's roughly the same accuracy. So that type of improvement is also possible. Okay, and finally, there is also the case of automated software transplantation, which we can again, frame as genetic improvements. The idea is you are going to borrow a feature from existing system into your own. And then this was the ACM Distinguished Paper Award winner at ISTA 2015. And it also won the HUMI Award, Human Competitiveness Award, given by ACM SIG Evo. at Gecko 2016. So we have many success stories around the GI community. If you look at the papers published at GI workshop, I was trying to find a few highlights, but then I realized I will probably bias the selection with my own taste, let's say. So instead, I collected abstracts from all the GI workshop papers and then produced this word cloud. You can look at the titles and abstracts from the genetic improvements webpage, which is the URL is at the bottom of the screen, genetikimprovements.software.com, and then there's papers menu. So you can go through them and find some interesting results or arguments for GI there, and you can explore more. So that's the brief introduction to GI, if I may call it that. So today's program, so we have Mark's keynote, which will follow this introduction shortly, and then there will be presentations for 5 position papers. So this is the first time we are doing this online, so I cannot guarantee that everything will be perfect, but this is our attempt to put order to things. So here's the protocol. The recommendation is everyone will remain muted by default because that will allow us to prevent any echoing of audio. And then we're not using any supporting system. We will try to do everything within Zoom. This is not such a massive crowd, so I'm hoping that this will work. You can either use the raise a hand feature. If you look at the chat window, then you can virtually raise your hand. And if you raise a hand, then I'm going to monitor the chat window and then I'll try to unmute you so that you can speak yourself. Or if you prefer, type the question into the chat. Again, I'm going to be monitoring that window and then I'll try to read the question at the appropriate timing. Do you have any questions about the protocols of the virtual workshop on Zoom? I'm seeing something in the chat window, so I'm going to check that. If I can find my cursor, that is. Wait. Okay. Right, I'm going to move on. So the schedule is we have allocated sufficient time for keynote, this introduction and the Q&A following the keynote speech. And then after that, 5 position papers, each will be given 12 minutes for presentation and brief Q&A. And then there will be a discussion session. We only scheduled 15 minutes, but depending on how things are going, obviously we can extend it until the discussion runs its due course. So the planned closing time is only a tentative planning. It doesn't have to end at that time. Okay, so I would like to thank Mark for being our keynote. I don't think he needs much introduction to the crowd within this virtual room. Today's title of the keynote talk is WES, appropriate because we have WES among the organizers, agent-based user interaction simulation on real infrastructure. So this is the next big experiment coming from Mark at Facebook. There is a funding call for research based on WES, as I'm aware. So I'm hoping that everyone will listen closely and maybe this will be a good preparation for the call. Is it still open, Mark?
Yes.
Yep, okay. So thank you. We want to also thank our program committee members. I'm not going to name everyone, but the reviewing process was very smooth. I ran many of the steps and then they've been super helpful. So thank you. And these people, although not being part of the official team, they helped a lot in terms of advertising and managing the website, etc. So Bill from UCL, Yue Huang from University of Michigan, and then Kabin is one of my students who helped with the web management. So this is not the only GI event. So there are many other things happening. This has been our strategy. So we are we're trying to collocate with any event which is relevant to the concept of GI. So if you want to check the whole thing, then obviously you want to check our website, which is again geneticimprovementofsoftware.com. There will be another GI workshop, but this time at Gecko. So far we've been having actually 2 workshops per year. One is at ICSE for the SE crowd, and then another one at Gecko for the genetic evolutionary computation crowd. And then there is one planned for Gecko, but I think actually Gecko is supposed to be happening either this week or next week. So it's actually closer together than the usual. There will be a special session on GI at CEC, another evolutionary computation venue, and then ASCE will have a GI tutorial. So all these events are added to the main website. So please visit the webpage if you want to learn more about these events. And then one final thing, reporting on GI. Last year, we had a publication as a result of having the workshop, ACM6 soft notes, titled somewhat in a grand way, The State and Future of Genetic Improvements. And that paper really sort of organically grew out of the post-workshop discussion and the notes that people took. And if enough people are interested in doing something similar this year, then we can obviously, try to do the same thing again. So let the organizers know either during or after the workshop if you are interested in something similar. So that's all from me. Thank you for submitting papers for the authors in the crowd and then also participants who came to listen to the talks. I'm personally really disappointed that the physical event is not happening this year, because I've been really looking forward to taking you to various places in Seoul, etc. But this is the best we can do. So, let's try to have as much fun as possible. Okay, that's it from me. So we are going to see into the keynote. So I'm going to stop my screen share and then Mark can start his. So while he's setting up, I'll try to give a brief introduction, except we need an introduction. So Mark is currently affiliated with Facebook UK and also as a part-time faculty member at UCL, where he used to direct the CREST Center. Full caveat, I'm one of his former students as well. And what else can I say? He was instrumental in starting the SPSE field, making it really active. And you can argue that the GI is a direct descendant from that movement, shall we say, applying meta-heuristic search to various aspects of software engineering. And then GI is maybe touching the very core of SE because it's playing with the software code itself. And I am actually quite intrigued that, although I looked at the paper and everything, I'm intrigued, and I want to hear from himself that how the web-enabled simulation will meet with GI as a platform. So that's enough from me. I'm going to hand it over to Mark for the keynote. Thank you.
Thank you very much, Shin, Bobby, Justyna, and Wes for the kind invitation to give this keynote today, and thanks to everyone for attending. I'm very sorry that we can't be in Seoul, but I hope everybody is safe and well and continues to be so. So today's talk is about web-enabled simulation, or WES, and Facebook's implementation of this approach, DubDub. We call it DubDub because it's a scaled-down version of DubDubDub, our World Wide Web offering. Just before I get started, Shin, could I just check in with you that my audio is okay and that you can see me just fine and you can see the slides?
Everything seems perfect.
Yes to all.
Great. Thanks very much. So yes, I'm Mark Harmon. I'm currently full-time at Facebook as a research scientist. I'm a member of the London Probability team at Facebook in London, and I'm also a part-time professor at University College London. So this talk is about a paper that I will mention and draw your attention to in the talk. And I just want to mention that it's joint work with all of these wonderful people that it's my great pleasure to work with at Facebook in London, all of whom are fantastic engineers and researchers in a team that really is a fusion of research and production engineering. So the goal of our team, like other teams in this overall organization probability team within Facebook, is to tackle longer term big bets that have a research character but that also seek to achieve impact. So we're trying to ride two horses at once, which is always challenging, especially if they sometimes go in different directions. But we try to keep them together, and we try to find that perfect resonance between scientific research and engineering impact. And as Shin mentioned, there is a funding call related to the research agenda I'm going to talk about today, and I will, at the end of the talk about that and how you can apply. The TLDR, in case you have to go early, is that it's a very light touch process, and the call is still open. And as you'll see in this talk, there's a very wide set of topics that are covered in this agenda, and so I hope there's something for everyone. So the context for our talk is that we're working with a platform that's used by 2.7 billion people around the world. It consists of hundreds of millions of lines of code on the server side, and on the client side, tens of millions of lines of code in the devices you operate on. So it's one of the largest scale software endeavors that the species has undertaken hitherto. And in an ideal world, everybody on the platform would be nice to everybody else, just as they are in real life. But that's not always how it works out. And so there are harmful behaviors that contradict our community standards. And we're continually trying to find ways to tackle these. Now, in this talk, I'm going to focus on scamming as a particular kind of harmful behavior when one user tries to scam another user. And in particular, that scamming approach will be achieved by crawling to search for target users to scam. But I hope you'll see, I'm sure that you will, that the kinds of technology that we're building and the scientific questions we're addressing are such that they can tackle a whole collection of other harmful behaviors. So I'll illustrate with scamming. So the starting point for our work is that we have the Facebook infrastructure. As I say, it's an enormous infrastructure. And by that, I mean the data centers and data warehouses that contain all of the information that essentially captures the social graph, and all of the processing that's done on that, the full stack of computation that allows one person in one country to send a message to someone in another country, possibly translated, archives it, makes it instantly available at arbitrary points in the future. So, as you can imagine, it's a very complicated infrastructure. And so one way of simulating something like this would be to build a model and then to write software that's based entirely on the model. But another way to simulate that we can only do with software, can't do it with any other engineering material, is that we can actually simulate on the infrastructure itself. So if you think about an aircraft manufacturer who's simulating the design of an engine, it's not possible to do a simulation on a real engine. You have to build a computer model. In fact, when you optimize that model, you are doing search-based software engineering because you're optimizing a software model of a real system. But software is a very unique engineering material. It's the only engineering material where we can build the simulation out of the engineering material itself, and therefore we can build our simulation to use the real infrastructure. And this is very important for the realism of the simulation. So what is a web-enabled simulation? It is a set of bots who are designed to behave somewhat like real users. And when the bots interact with each other, they do so using the real infrastructure that any normal user would use. So the actions that the bots perform and the observations that the bots make are exactly the same actions and observations that a real user could make. And when they make those actions and observations, they go through the same code stack as real users' actions and observations. So in this case, we're interested in harmful behaviors. And so we're going to reward these bots for being bad to each other, because we want to try and simulate the kinds of harmful behavior that can happen on a platform like ours. I should stress at this point that any and all interactions in DubDub, in our web-enabled simulation, are between DubDub bots and other DubDub bots. Okay. So the bots are completely isolated from production. And we do this in multiple ways to be absolutely sure. So we have a kind of belt and braces approach. The bots are first of all carefully constrained in the actions and observations they can perform. And so by construction, they can only communicate with each other. The interactions they make go through a mechanism layer, which we'll talk about in some detail later on in the talk. And this adds an extra layer of checking. And finally, the existing privacy mechanisms are also designed to insulate the bots, just should any of these other layers fail. So I said that we're going to focus on harmful behavior, and in particular, scamming behavior. And in order to model that, we essentially want the bots to crawl around the social graph. So we're going to reward them for crawling using the Facebook infrastructure. And so to them, to the bots that is, the social graph looks much like a graph, as a graph theorist would recognize it. So it has nodes and edges. A user is a node, and there are many, many, many edges, but the one that we're going to be looking at is the friendship edge, the most basic one in the social graph. So users have other friends who are users, and so edges are friendship and nodes are users. So we put these bots into the social graph, and suppose this is a completely innocent bot, while this bot is a less innocent bot who's trying to find other bots to scam. So what happens is the bot crawls around the social graph, interacting as it goes with the bots it finds, and this might direct it in the crawl to find a potential target for its scamming attempt. So it makes a scam attempt. Now, in order to train the bots to behave in bad ways, we need to consider what it means to train a bot. So we have three approaches, and they are in increasing orders of complexity. So the simplest is just a rule-based approach, essentially old-fashioned expert system style AI, nested if then else's, if you will. So rule-based behavior that we've implemented and played with is essentially a depth-first search. The bot goes from a friend to a friend list to that friend's friend list, and it goes depth first. When it reaches a place where it can't find any more friends, so at each stage it'll choose a friend to go to, and then it'll go to that friend's friends and that friend's in a depth first fashion. But when it reaches a place where it can't see any more friends available, maybe because that user doesn't have any friends, but more likely because that user has privacy constraints that means that no friends are visible, then the bot will backtrack. And so this is a simple depth-first graph search. And that's the simplest way that we can train a bot. You might argue that it's not even training, it's just an algorithmic approach. The next most sophisticated approach is to use supervised machine learning. So we're fortunate because we have so many users that we have an enormous amount of data that we can harvest to train bots. And we can use this in a supervised machine learning system to produce a prediction of what the bot should do if it wants to emulate certain kinds of real user behavior. So we use supervised machine learning. The way that works is we connect anonymized data, of course it is anonymized, and we learn generalized patterns at scale. So we're not interested in modeling the behavior of a particular user, we're interested in modeling the overall gross course level statistical properties of a class of users in general. So for example, what scammers might do or what normal users might do, given a set of choices about where they might navigate to in the social graph. And so what we're really doing here is we're training the bots to imitate reality. We're training them to do things that we've already seen that real users do, but at the level of abstraction where we're only interested in the emergent coarse-grained statistical effects. And the most sophisticated kind of training we do is unsupervised machine learning. This is where our work touches on some of the research on AI-assisted gameplay, for example, because essentially what we're talking about here is a reward-based approach where we don't tell the bots how to behave. We don't even train them on real behavior, but we define a reward criteria. The environment issues these rewards, and then we train the bots using reinforcement learning. All three of these have been implemented in our current DubDub, and we're experimenting with them. I should stress, however, at this point that this project's been running for less than a year, and at this stage it is more of the character of a research project, but things move fast at Facebook, and I hope that by this time next year we'll be talking about real impact on the production code. We're just at that point now where we're starting to see and learn from the ways we've trained the bots and understand how they imitate reality and the kinds of things they discover. So let's imagine we're training our bots to do crawling, and we're interested in essentially battle testing the existing infrastructure that we have at Facebook for detecting harmful behaviors. So in this case, the bot that's simulating a bad actor who might perform harmful actions is going to perform actions trying to reach a bot that's otherwise modeling in a completely innocent user. So the bot will perform actions, but it shouldn't be able to interfere with this user, and our infrastructure is designed through various machine learning trained classifiers to detect this. And so the idea is that we can use dub and the general idea of web-enabled simulation to catch these kinds of behavior and detect whether our existing detection systems will detect them. So it's particularly useful, for example, when there's a change to the code, because once the code is changed, the existing detection systems may be seeing something they haven't seen before, and so we have to see will they adapt to that, to what extent are they generalized. The Facebook infrastructure undergoes at least over 100,000 code mods per week. So there are a large number of changes, and having a framework in which we can investigate the effects of changes on real users is, of course, very valuable, as you can imagine. So I want to pause at this point and just draw your attention to the research paper that accompanies this keynote. If we were actually physically at the conference, I'd be able to sit and have a coffee or something perhaps a bit stronger with you and go through the paper with you. But I haven't got that in this virtual environment. So what I'm going to do is I'm going to spend 10 minutes, if you'll indulge me, to actually take you through the paper and point out some of the things that I think are interesting in the paper, and I hope that that will encourage you to read it. So the paper's title is WES, Agent-Based User Interaction Simulation with Infrastructure. And as I mentioned, there are 12 authors of this paper, and that is the team in London. It's actually, there are more people in the team now. The team's growing all the time. This was the authors at the time we submitted the paper back in March. And the first thing you'll notice is in the abstract, we talk about the number of different fields that we need to draw on in order to get scientific ideas to help us build this research agenda and this specific instance of the agenda, the dub platform that we're developing at Facebook. And you'll see there's a very wide range of topics. And so when I talk about the funding bit at the end of the talk today, I hope there will be something that almost anybody listening to this talk and maybe many of the transitive friends of those people in the scientific community would be able to consider and submit to. So one of the important things about our approach, I think, is that this isn't really just something for Facebook. The idea of having an infrastructure through which one user can communicate with another user is not something that's peculiar to Facebook. Many organizations now offer the ability through their platforms for users to interact. So, for example, booking systems will typically have rating and reviews. App stores offer this, travel companies. Increasingly, almost all of the ways in which we interact with software allow us to communicate with other users in a social way. And so software in general is becoming more sociable, and it's becoming a mechanism by which we communicate with each other. Even software that isn't designed to be social, isn't designed to be a social media application. So obviously at Facebook, we're peculiarly and importantly concerned with social interaction. And so I think it's a good company to be trying to take a lead on developing web-enabled simulation. But I think that we certainly shouldn't and won't be the only people to be able to benefit from this approach. And we'd love to share ideas with other people and to collaborate and to learn from what other people are doing in this area. There's far too many scientific questions for us to be able to tackle all on our own. And so we're very open to learning from other people's work in related areas. The other thing about a web-enabled simulation is, as I mentioned at the start of the talk, because we're using the real infrastructure, that means that our simulation can potentially have greater realism. So when one user sends a message to another and it goes through the real stack, that simulation is taking account of all of the nuances of the software stack that might affect the way that message arrives at the other user. And therefore we can pick up all sorts of bugs that you wouldn't pick up in a traditional simulation where you build a purely model-based approach. It's not running on the real infrastructure. That's one advantage and one thing that makes a WES approach different, I believe. So moving on, I think one of the things that's important about this agenda for us is the fact that it does raise so many questions. And as I say, we can't answer all of them. So I will talk at the end about how we have a funding call out, which I hope people will consider applying to. Of course, in the paper, we do actually describe the overall approach to web-enabled simulation, introduce some terms and concepts. I'm sure others will be able to build on these and maybe even refine them and possibly refute some of them. This is our first stab at trying to characterize what it means to be a web-enabled simulation. And one thing that I think is particularly interesting, and perhaps especially for the genetic improvement community, is this idea of a mechanism. So I'll come back to that later on in the talk. So naturally in the paper, we talk about the need to train bots. It's important that they have behaviors that are somewhat learnt. And it's also important that they are isolated because we are running on the real infrastructure. So we need engineering solutions that isolate the bots from production. Perhaps one of the most interesting things, I think, is the idea that we might be able to do this approach we call automated mechanism design. So I'd like to spend a little bit of time unpacking that. So if we look at figure 1 in the paper, we have this concept that there is the platform infrastructure. It's the real Facebook infrastructure. And we have real world bots, the real users, excuse me, not real bots, the real users who use that infrastructure. And then we have the WES bots that also use that same infrastructure, but between the two, there's an isolation layer. Different organizations could implement this in different ways. I explained earlier on how we do, but it's important that the bots are in their own isolated world, but on the same infrastructure. But in between the bots and the infrastructure, we can have a mechanism. What do I mean by mechanism? Well, what I mean is the bots have to communicate with the infrastructure, but since they're not real users, we can impose a layer that mediates, possibly transforms the actions they can perform and the observations they can make. And this mechanism allows us to simulate all sorts of ways in which we could change the products, but in a very light touch, easy to deploy and investigate manner. So we're going to talk about this more later on in the talk, but I just want you to imagine, suppose I could constrain the number of messages that a bot sends to another bot to a certain number of messages per minute. I could do that by going into the code and finding the code where messages are sent and putting in all sorts of checks to see if it's a WES bot, then don't check the rate limit and so on. But that's very expensive because the infrastructure is hundreds of millions of lines of code. And it's also used by real world users. And it's not necessarily the best way to experiment with what it would look like if bots were constrained in their message sending to go in and edit the real code. This might be how we would do genetic improvement, but what I want to talk about to this community is that the possibility that we might actually raise genetic improvement to be a layer that we interpose between the user and the software, in this case, the user being bots. And that allows us to search much faster and more effectively for product changes at the mechanism layer without actually having to change the underlying code. In genetic improvement terms, probably the closest idea is the so-called API constrained genetic improvement. So we call this automated mechanism design because we don't just want to model this mechanism, but we want to be able to think of it as a search space and automate the search in that space. And so we think of this as a kind of a search-based software engineering problem where the mechanism space is the search space. And the thing that's really exciting about this, I think, is that many organizations like Facebook do A/B testing. but it's quite a slow process. If we could simulate real users on the real infrastructure and use mechanisms to search the different kinds of products that we might offer and the ways we might constrain and enhance them, then we could do that orders of magnitude faster than we could with A/B experiments, and in a controlled environment, a more experimentally controlled environment. So I think this idea of automated mechanism design is a potentially interesting and exciting one in the paper. I'd love to discuss that with people. And there's another idea I wanted to draw your attention to in the paper, which is this idea of social testing. So what is social testing? Well, the way we arrived at the realization that it would be beneficial to have bots interacting with each other partly came about through consideration of how our existing infrastructure automates testing. So as people may know, we have this Sapiens technology, which is an automated search technology for automated test data generation. And as many people who research testing know, you want to prevent your tests from being flaky. And one way in which tests could be flaky with Sapiens is if the test users started communicating with each other. So if I'm trying to test a new product feature for message sending, and the Sapiens test user that I'm using to test the client side with starts sending messages to some other user who might respond, some other Sapiens test user, and that test user starts responding, that's going to make the test very flaky. So we put in some effort to try and prevent that from happening. But it's set us thinking that, well, actually, suppose we made a community of test users that do communicate with each other. Then we could test other kinds of properties of the software, properties that only really are witnessed when we're at this social level. So we call this social testing. And I want to stress that I think the WES agenda goes beyond social testing, but it kind of subsumes it. So social testing allows us to test interactions between users as opposed to interactions between one user and the platform. But WES goes a bit further and says we don't just want to test these interactions, we actually want to train the bots to behave in adaptive ways, to simulate social interactions between the users. So we're not necessarily just interested in finding faults in a platform that might affect that interaction between users, but ways in which the users might harm each other by those interactions and how we could possibly improve the underlying platform to make that less likely to happen. So to characterize what we mean by social testing, if you think about traditional end-to-end testing, it's really about a single user's journey through the system. So whereas unit testing is about an individual parameter's journey through a module or a set of parameters, end-to-end testing is about the whole system. So it's a journey of you can actually now, a user becomes a meaningful concept and the user goes through some story, some use case through the system. But it's still usually a single user. We might test with multiple users, but that's just a scaling up. We're not really interested in how those users interact with each other. But with social testing, what we're interested in is the kinds of faults that are best explored and debugged at the community level. So we did some initial research on this, and we found that approximately a quarter of the most impactful production bugs that we see at Facebook have this social character, the kind of thing where you don't really notice it when you're testing end to end, because one user's journey may be fine, but when you run at scale in production, suddenly you notice that some of your coarse top-level metrics, the percentages of messages sent, might change. And these kind of emergent properties can only really be explored using a social testing approach. The other good news is we found that about 10% of these have an automated oracle. So as testers will know, the oracle problem is particularly challenging and pernicious. But for this social testing problem, it's not so bad. So one of the applications of web-enabled simulation is a vehicle to implement social testing. And in our paper, we talk about the way we've approached our own implementation of web-enabled simulation in our system called DubDub. And we describe its implementation, of course, how we train the bots. That's actually changing all the time. So the talk I gave earlier on about this is more up to date than the paper. We discussed the implementation, and of course, we discussed some of the applications of web-enabled simulation, and the ones that we're exploring with DubDub, our own web-enabled simulator. And in this talk, I'm particularly going to focus on integrity, and that's what we're currently tackling in our research and practical work at Facebook at the moment. But I wanted to mention that the overall approach also applies to privacy. And as I mentioned earlier with the idea of social testing, I think that web-enabled simulation can be a very useful additional tool in our armory to tackle reliability. It kind of sits above end-to-end testing as a kind of social level testing where we're looking for these social bugs I mentioned. And one exciting thing about that is that though we're at a very high level of abstraction, there are very valuable oracles, because the same oracles we use to detect faults in production can now be pulled back into the simulation layer and used to detect those same kind of bugs before they hit production at the social interaction level on a web-enabled simulation. So we conclude the paper with a set of open problems and challenges. And this is where I hope the paper is most valuable and useful to the readership, because, as I mentioned earlier, we can't possibly tackle all the questions that we need to. That we need the scientific community to address the underpinning scientific research questions that this research agenda opens up. And there are many. We list, I think, 14 in the paper and try and give some kinds of initial pointers to the literature that we're aware of that we think can tackle those problems, but it's not an exhaustive list. And you can see we spend 2 pages of our 8-page paper on this problem. So I hope you'll find the paper interesting. I'd really love to talk to anybody who's read the paper. I'm happy to talk through direct message or in the questions after this talk. And I'd like to conclude this part of the talk by thanking all the many people at Facebook who contributed to it. Not just the 12 authors of the paper, but Facebook's open engineering culture has meant that we've received feedback from many, many tens, if not hundreds of engineers, managers, data scientists, analysts, all sorts of people on the development of this research agenda and the DubDub system. And we've also been very fortunate to be supported very strongly by the leadership of the company that's given us the freedom to essentially embark this year on a research project with the goal of turning this into a big bet that we hope will have huge impact next year. So as you can see, it's not a long paper. It's about 8 pages. I think it might be 10 with the references. There are quite a lot of references, but it's not that long. It probably is a half-an-hour read, and it's not challenging in any way or depth. But I do hope and believe that it has some interesting possible directions and avenues for future research. And we're certainly going to be actively pursuing those, and would love to collaborate and talk to other people who have ideas. So in the last 10 minutes of the talk, I'd like to focus particularly on this thing we talked about in the paper called mechanism design. I personally feel that this is a very exciting avenue. It's only one of the many things we're working on. And it's only one of the things that you can do with web-enabled simulation. But it's possibly the one that most draws on the research that is relevant to this workshop. So I'd like to spend 10 or so minutes on that. So I mentioned that we're targeting harmful behaviors, and we're looking at scamming in particular in this talk as an illustration of those. But wouldn't it be good if we could, instead of just detecting harmful behaviors, if we could actually automatically prevent them, or at least make it much harder for harmful behavior to take place, to increase the friction that a user with bad intent would experience if they try to engage in harmful behaviors. So we're interested in this tension between detection and prevention. From a research and scientific point of view, this is a very interesting tension as well, because there's quite a strong analogy between detection and prevention in this scenario and detection and prevention of other things in software engineering and computer science. So for example, side effects. If you ask, can I detect whether this particular unit of code has side effects, if it's Turing complete, then the question is undecidable. But if you ask, can I transform this program into a guaranteed side effect free version, that's open. That may actually be totally decidable. You square the circle because the transformation may affect it and may disrupt a program that was purely side effect free to start with. But you give the guarantee that the transformed version is side effect free. So without needing to detect side effects, you can use a transformation that will guarantee to remove them if they exist. Similarly, in other walks of life, there's this interesting interplay between detection and prevention. You might think that in order to prevent something, you need to first detect it. After all, isn't preventing something kind of harder than just detecting it? But actually, in all walks of life, we're used to the idea that prevention is easier than detection. Let me give you an analogy with just totally not connected to computing. So suppose you're on a lovely sunny day and you're driving along the road in your camper van, enjoying the sunshine, listening to some delightful music, and then suddenly, out of the blue, a car zooms past you, way past the speed limit, nearly knocks you off the road. You're cursing, you're frustrated. Not really a lot you can do about it as the driver of the camper van, but as the road designer, you can do something. As the road designer, you can consider ways to detect and prevent this kind of bad behavior on your platform, on your road. In the UK, speed cameras are painted bright yellow like this. This is exactly what they look like. The idea is that although this is a detection technology, we'd like it to be a prevention technology. So if you see a big yellow box, you might slow down, and therefore we don't need to detect that you've speeded. Of course, it is fundamentally a detection technology. And the problem with that is that although it can generate revenue by charging people for speeding, the bad thing has happened by the time it's done the detection. Contrast that with prevention approaches. Excuse me, I'm too fast through that slide. So contrast that with prevention approaches. So prevention approaches, we put a speed hump in the road. The idea of a speed hump is that it's actually physically impossible to speed, while at the same time, you don't hurt someone who's driving at a normal speed. And neither of those things are true, and that's why speed humps have rather a bad reputation with drivers. So normal users will experience the speed hump, and it will tend to degrade their experience of driving, and might also degrade the quality of their car faster than if there weren't speed humps. Similarly, people can speed. It makes it even more dangerous if they do, because they're going over these humps. But nevertheless, even given the fact that this technology has those two problems and limitations, speed humps are very popular as a way of preventing bad behavior on roads. Now, in mechanism design, we're interested in putting virtual speed humps into software. But the interesting thing here is that software is so much more flexible and subtle and malleable than the physical engineering materials that we build a road with. So just as our web-enabled simulation can use the real infrastructure, the fact that our engineering material is software, not tarmac and concrete, means that we can potentially design incredibly subtle and sophisticated mechanisms that may have a very good chance of not being even noticed by any normal user, but still producing considerable friction for a user that's trying to cause harm. And so I feel like we're in a sweet spot as an engineering community because we're so fortunate that we have this engineering material that has these properties. So how does this play in our web-enabled simulation? Well, we're rewarding our bots for crawling, and they make these actions and observations on the real infrastructure. But we can impose constraints on the actions they can perform and on the observations they make. They may not be purely constraints. We might actually enhance some of the actions and observations that happen. So think of this as a transformation. But in general, it's a transformation. I think it's useful at this point to consider it as a kind of constraint vector, because then it's much easier to see the connection with search spaces. So imagine each bot has its own constraint vector, and that constraint vector is a set of numbers, essentially. Could be non-numeric, but anyway, a set of parameters that constrain the way that particular bot can interact with the underlying infrastructure. So this bot can only send 4 messages a minute, can only see 12 messages a minute, and can only make 17 friends a week. I picked those numbers out of the air, of course. This bot, by contrast, has different parameters, and the third bot maybe is a mixture of the first two. So like the second bot, it can see 22 messages a week, but like the first one, it can only, sorry, it can send 22 a week, but like the first one, it can only see 12, and so on. I'm sure you can imagine we would have potentially thousands, maybe tens or hundreds of thousands of bots, each with their own constraint vector, each able to exchange these constraint vectors and bits of the constraint vectors with each other in order to explore the ways in which we could fine-tune the mechanism by which the bots are communicating with the infrastructure. And by extension, that fine-tuning is exploring the ways in which we could genetically improve, if you will, that infrastructure by changes to the product code, such that real users would have perhaps a better experience on the platform, and users intent on committing harm would have considerably elevated friction in their efforts to cause that harm. So of course I've drawn this constraint vector as if it's 3 elements per bot, but in real life, in our infrastructure, there are thousands of ways we could transform, probably tens of thousands of ways we could transform even some of the simplest interactions. And so what we have here is an enormous search space, a mechanism search space. And what we're looking for is a tiny set of changes, perhaps only one, but maybe several small changes, which collectively together will give us this virtual speed hump, which is only experienced by users intent on harm and doesn't even get noticed by normal users. Perhaps even in a multi-objective way, we could improve the experience of normal users while decreasing the ability of harmful users to cause harm. So you can imagine that if we have this large search space and we're trying to find that small set of values that might give us this virtual speed hump, then it's a bit like searching for a needle in a haystack. But we're very, very fortunate as a research community because over the last 2 decades, the software engineering community has been investigating exactly the kind of techniques that are well designed to find needles in haystacks in software search spaces. And this area is, of course, known as search-based software engineering. And so where we're at currently in this project is we're able to train our bots in various different ways I mentioned. We can simulate real behaviors of interest. We're calibrating those against those behaviors in production and checking that they are actually faithful. And we're experimenting with different kinds of mechanisms. And where I hope this research agenda is going is to explore those mechanisms automatically, scale up our infrastructure further, and thereby be able to automatically find mechanisms that will improve our software. It's a kind of genetic improvement. As I mentioned, there is a funding call. I must stress, although this is the genetic improvement workshop, this funding call is open to all sorts of topics. We list in the funding call, I think, 12 or 15 different areas of computer science that are relevant. And there are many more that are relevant that we didn't list. So it's definitely one of those topics include, but are not limited to. The deadline is the 15th of July, which isn't long, but all we ask is a 2-page proposal. And the awards we make and those to whom we make successful awards, we'll get that as an unconstrained gift. So we make absolutely no constraint on how you spend the money. You can spend it any way your university or your research institution allows. And there'll be, I think, up to 8 awards and up to 50K each. And we've tried to make the process of application as light touch as we can, notwithstanding the fact that we need to have sufficient material, obviously, to evaluate the proposal. And I want to stress that we're interested in the fundamental science here. So these proposals need to tackle the fundamental scientific questions we raise in the paper, but they don't need to be relevant directly to Facebook's applications. You can evaluate your work on completely different open source frameworks. You can build totally different systems to us. You can challenge the assumptions we make. In fact, we'd encourage you to do that. What we really want is to stimulate the basic science here. If you're interested in actually collaborating with us directly on our system, then there are other routes through, for example, internships and contractor work. But
we want this funding call, this request for proposals, to support the basic science underpinning this general agenda of web-enabled simulation, which I hope will find application and interest far beyond just our own company. Thank you very much for your time and consideration and for listening to the talk. We have 15 or 20 minutes now, and I'm very happy to take questions.
Okay, thank you, Mark. Virtual hand clap. I'm going to open the floor for questions. Does anyone have anything that they want to ask? You can, again, raise your hand or type it in the chat window.
You can ask about the funding call as well if you want.
Okay, so Wes is saying, could you expand a little bit on your observations with social testing? At first blush, it seems similar in some ways to multi-threaded or message passing program testing, in that the interaction between threads, the message passed between them, and the order all matter. But it seems like there's something special here beyond that. And alternate phrasing would be, what are those 25% of social bugs like? Can you describe a few?
Okay, so I will describe one, but I want to stress that I'm making up this example. This isn't necessarily something we see at Facebook, because I can't talk about real bugs for obvious reasons. But imagine you're in an organization where you have production metrics that measure the kind of health of your infrastructure. So you might measure the number of messages sent. And what happens is developers are putting up changes to the code all the time. And then on Monday morning at 3 o'clock, you suddenly notice that the number of messages sent has dropped by 50%. Now, all the tests passed. You had tests that do race conditions, multi-threaded tests, and so on. They all ran end to end. But what happened was there was a particular code path, which if this code path is executed, then messages will be dropped. But actually in the testing, that code path wasn't executed. Of course, that's quite common in testing. We can't exhaustively test. And so we pass all the tests, but as soon as this change hits production, we very quickly notice an alarms start ringing and dashboards start blinking red, because this bottom line metric that's measuring one of the fundamental properties of the infrastructure changes. And so most organizations, Facebook isn't alone in this, any organization that has web deployed systems has these automated alarms in place and has a DevOps type culture, and those alarms will wake up an on-call, and the on-call will have to panic and try and work out what's wrong and fix the bug in production. So what social testing is saying, well, if that happens in production and there are some bugs that you just, although you could have found it in earlier, it's a bit like with end-to-end testing. You know, when you have an end-to-end test that fails, you think, well, how could we have caught this with a unit test? And for sure, any bug that you can find with an end-to-end test, you could have found with some unit test, but you didn't. Right? There are some, but it's just better to have this extra layer, because there are a whole class of unit tests you'd need, all corresponding to one error manifestation at the end-to-end level. And I conjecture, in fact, I've seen evidence that there are a whole class of end-to-end tests that would map onto one very obvious error manifestation that you would see in production. So suppose we can pull back from production because we have this social interaction between these simulated users. Now, instead of waiting till these bugs hit production, we can recognize them through the same dashboards that would wake up an on-call, but in our simulation, such that when changes happen, they first go through the simulation before they hit production. Now, there are all sorts of issues here, like some changes can't go, haven't got time to go through that. There's a soak time and so on. But intellectually and theoretically, I think it's really interesting to consider this higher level of abstraction. And what distinguishes it from the kinds of testing you were talking about, Wes, I believe, is that it's the kind of bug which only manifests when a large number of users are interacting together. And the bug the oracle is some sort of statistical property of that interaction rather than any individual user's experience. I hope that answered the question. We call it social testing.
Okay, do we have any other questions?
We actually have one on the YouTube live stream, which I think I'm going to allow because I don't see why not. Matthias asks, in the paper, one of the areas in which you say WES can be applied is mining software repos. And he's asking if you can expand on that.
Yes, that's a very interesting question. So many people ask us, well, if we're to apply for this funding, then do we have to use your infrastructure? And the answer is no. In fact, at the moment, we haven't made it open source. I mean, Facebook has a very good habit of making core infrastructure open source, but at the moment, we're still building this infrastructure, and there are no current plans to make it open source. However, there are many, many other platforms that have this social interaction character. And one of those are continuous integration platforms, repositories and so on, mechanisms through which developers do code review. And therefore, one way in which researchers could experiment with ideas of web-enabled simulation would be to consider some of the work that's been done on mining software repositories and consider the repository as a platform through which people interact. And then to bridge from that, from some of these some of these interesting questions in the MSR community about how software engineers interact with each other and with the code, to thinking of that as something that we could simulate and use bots to simulate real developers and explore ways in which changes to the continuous integration, the code review process and so on might actually make their job easier, prevent certain kinds of harmful behavior between developers or between developers and code. So that's the sort of thing we had in mind. But I'm sure there are many, many other ways in which mining software repository work could yield insight for us.
Okay, I have a couple of more questions in the chat window. So I'll first read one from Myra. So to follow on to S's question, is there some general profile or characterization of how this work, that is, do we see large numbers of interactions leading to bugs or small numbers, or are these distributed evenly or clustered? The characteristics of how these interactions happen seem to suggest potentially different approaches.
Thanks, Myra. That's a very, very astute observation, and you're absolutely right. Yes, so once we start thinking about social testing, then you get into demographics. So it could be that certain bugs are only experienced by certain subclasses of user community. Maybe a classic example would be any kind of date-related bug will first be experienced by users in New Zealand because they're the first to cross the date line. And so that's just one very specific example of a demographic social bug that might manifest in such a simulation. But you can imagine all sorts of statistical properties that you could observe in production that would either affect all users, those would be the easiest to observe and would need the smallest sample size. You know, with perhaps just 100 bots interacting, you get enough signal to detect statistical properties. And others would actually be much more challenging because maybe they only affect a very small slither of demographic of your user community, but one, those users still need to be looked after. And so there is the interesting possibility that for many organizations, not just Facebook, but for many that use these production level metrics and alerts, because they are relying on core statistical properties, there are many bugs, social bugs, which they're not detecting and which just lie in the software and may affect particular demographics that they're either unaware of or that are hard to characterize or that the metrics just don't currently cater for. But by bringing this forward into the simulation, where we have much more scope to play with controllability, where we can do research on different kinds of ways to map demographics to kinds of social bugs, I think the research community can make a tremendous contribution here. And this research could actually help many organizations, as I say, not just Facebook, to find all sorts of social interaction bugs which are currently actually not being detected.
Okay, I I have one more from Bill. Can you say more about how GI on the automated mechanism design will work? For example, what would be the fitness function and how will it integrate with A/B testing?
Thanks, Bill. Yeah, good question. So the thing about A/B testing is it takes time and it involves testing in production with real people, and that's difficult in all sorts of ways. The nice thing about being able to do web-enabled simulation is that you're testing on bots, and so the kind of fitness functions we might imagine would naturally be multi-objective, because if we imagine I just tell my mechanism design algorithm to find the mechanism that will prevent bad behavior, it would just essentially zero out all of those parameters until nobody could send any messages to anyone, whereupon it would achieve maximal fitness, because no one can do any harm, but also no one can do any good. So it's a natural multi-objective formulation where you need one objective at least that's measuring the ability of normal people to go about their normal daily work on the platform, and one that's measuring the ability of those with harmful intent to achieve their harmful behavior. So any kind of fitness we adopt would need at least two fitness functions in tension with each other. So we're in that classic world that's been well studied in SPSE research of multi-objective optimization. I think I may have forgotten the rest of the question. I know that part of it was about fitness functions, but I think Bill asked something else. Can you remind me, Shin?
How will it integrate with A/B testing?
Yeah, so the idea of mechanism design is that we're doing this in simulation in order to scale up by orders of magnitude the amount of experiments we can do. So if you think of an A/B test as an experiment, then imagine in a simulation we could do several orders of magnitude more experiments and in a much more controllable way. But the end product of those experiments is a recommendation for something that would then presumably be A/B tested before it then hit production, because you still have that ultimate question, which is, yes, okay, so that's what happens in the simulation, but would the same thing be observed in reality? The nice thing is, if it is observed in reality, then that's a win. If it's not observed in reality, in a small A/B test, then that's feedback for the simulation, so we can then use that to improve the simulation. So there's a nice symbiotic relationship between controllable, laboratory-style, scalable testing in simulation and the feedback that one gets from A/B testing that all organizations use.
Okay, the next question is probably relevant to the last point that you just made. This is from Sungmin. Thank you, Mark. Assume I found a suitable mechanism that prevents bots from doing a scam. Would it work on real scamming human users too? Maybe it would be such an easy mechanism so that users will quickly adapt to the mechanism and keep doing the scamming while bots cannot.
That's a very good question. A very good question. So version 1 of mechanism design is, let's see if we can model mechanisms and search them ourselves as humans using our intellect. Version 2, we automate the search, and now we find mechanisms which, for pre-trained bots that behave like behaviors that we've seen, those behaviors will be prevented. But as you rightly point out, this is kind of like an arms race where those who are intent on harm may not just give up at the first sign of trouble. Some will, but not everybody. So we're in an adversarial scenario to some extent there. And the interesting thing there is that there's nothing to say that bots can't learn to overcome the mechanism. It's just that that would require that most sophisticated of training mechanisms that I alluded to in the earlier part of the talk, reinforcement learning. So instead of training the bots to imitate bad behavior that we've seen and then try and prevent that by searching for a mechanism, that would be version 2. Version 3, which is still currently a very open research challenge for us, and not something that we'll probably be working on, not before the end of this year anyway, is that we frame our problem as an adversarial one where we use reinforcement learning to train bots to try and achieve the bad goal, but without telling them how to do it. And we search for mechanisms which can thwart all comers. So now the mechanisms can adapt to the learned behavior of the bots. And similarly, there's nothing to say that we just learn a mechanism, deploy it, and then we're done. You know, this technology inherently can be iterative. and can be quite fast to adapt. So you can imagine a scenario. I want to stress this is very challenging and far ahead in the research agenda, but you can imagine a scenario in which the mechanisms are themselves adaptive.
Okay, we have a couple of minutes left, and I wanted to ask something as well. So I'm going to steal the last spot probably. So we are talking about things like scamming between Facebook users and detection and prevention of harmful behaviors on a simulated platform. And to me, it sounds like a lot is depending on how realistic the bots are. And then the thing that I'm having trouble with is, suppose we have a bot which is trying to scam another bot. But how does it happen? I mean, is it at the semantic level? It will post a tricky photo, or do you have a symbolic way of representing that? Then all of this, the abstraction level or the granularity of the actions of the bots will have impact on what you observe on the simulation, and you may just get this the so-called the butterfly flutters its wings, and then you observe something totally different on the outside. How do you going to manage that?
Yes, that's a very interesting question. Thank you, Shin. So I hope you'll forgive me if I don't go into into details about particular modes that bad actors will use, because that's not a good idea for us to reveal how we're tackling some of those behaviors. But to come to the general scientific point that you make there, which is essentially, well, there'll always be some kind of special corner case that your bot didn't really simulate, and so your mechanism by definition won't catch that, and therefore, how you deal with that. And I think this really alludes to the difference. It's a bit like the difference between verification and testing in a way. So we're not building a system that will guarantee that bad behavior is impossible. In fact, I'm not sure such a system could exist, but I'd be very excited if it could, and if it does, then it'll come from the verification community, I'm sure. But what we are trying to build is a way, it's more of an engineering approach where we can try and reduce the prevalence of this behavior by changing the mechanism. So if you think about the kinds of behavior that the bots need to exhibit, they don't need to perfectly model human behavior. They just need to model sufficiently coarse-grained statistical properties that when I say this mechanism is better than that mechanism, there's a good chance that that's a true assertion in real life. And so the bots need to be good enough that on average, I've got a good chance that saying this mechanism is better than that one in simulation implies it's better than that one in production is a true statement. And that's actually much, much less challenging than saying, can I make a bot that perfectly emulates the behavior of a scammer such that it could pass the Turing test?
Okay, thank you very much. I think we are we need to move on to the paper presentations. So
thank you very much. Thanks for all your lovely questions. Happy to chat offline.
Okay, and I'm going to hand it over to Bobby, who's going to chair the paper sessions.
Okay, thank you, Shin. Very interesting keynote presentation. So we've got 5 talks today, each will be 12 minutes, 7 minutes roughly for presentation and 5 minutes for questions and answers. One thing that didn't happen in this keynote Q&A, but I just want to make clear that if you've asked a question that's currently being answered, feel free to unmute yourself so you can kind of respond to the questions being asked. But yeah, apart from that, there's exactly the same procedure as before. So our first paper is going to be Checkers Multi-modal Darwinian API Optimization. And I believe Michail Basios, I hope I'm pronouncing that reasonably okay, will give the presentation. Are you ready?
Yeah, can you hear me?
Yes, you're
okay, good.
Yes. You should be able to screen share, so start when you're ready.
Yes, thank you very much. Thank you, Mark, for the very nice presentation. It was really useful to see how Facebook is doing things on another scale, which is always very difficult from the research. So first, let me introduce myself. So I'm Mike. I finished my PhD at UCL. under the supervision of Earl Barr. And after I finished my PhD with some other students of Mark from Krauss Group, which was Fan and Lingbo, who are experts in the GI, like their research was in genetic improvement techniques, as well as Leslie, who is more expert in machine learning, and he did a PhD with John Shaw Taylor. We we started a startup actually, which we are building an optimization platform that applies genetic improvement, genetic programming techniques to the wider industry. And more specifically, we want all the advanced techniques that in the research we are building and others are building to be available to the wider industry, not only to big companies like Facebook, Google, and others. So we are a very much research-based company and group, and we have other students from UCL as well that finished and other universities. And in this paper, we will present our research work that we are doing with Santanu, who is a postdoc from UCL and currently a reader at Surrey University. And this work is about it's kind of a combination of our previous work, which was Darwinian data structure selection, which we show how we can apply genetic improvement to optimize the performance of code by changing data structures, and also dual channel analysis and some work that Santanu has done with his group on understanding better the code by combining both static analysis and machine learning on comments and documentation to analyze better the performance, to better understand the code. So one of the main problems that we have seen when people want to apply genetic improvement is that in which area of an application you are going to apply genetic improvement so you can make it, so you can improve non-functional properties. Our main focus on the people that we have been talking with, their main performance optimization, their main metric for performance is execution time, memory consumption, CPU usage. So when we analyze this application, we see that nowadays there is a huge trend of API first development of applications, and we see that applications have a lot of external libraries. And when people usually write an application, there are a lot of equivalent libraries in the form, either a library or an API, and it's quite tricky to know which library is better than the other one. For example, if you want to implement an application in Java or in Android, on GitHub, there nowadays are very popular the awesome Java, awesome Android, awesome C++ lists, which usually developers look and they can see the alternative APIs that they can use on the library. So what we wanted to do is that we have seen this behavior, and actually we have seen that the performance of an application is affected very much by the selection of the API that you will use. We have seen also that nowadays with this approach of API first, and we see a trend where even very old code bases that were very isolated, now they are in the approach of exposing more and more APIs. For example, I don't know if you're familiar with the open banking system. If you go into and talk with the biggest financial institution in London, now they all are trying to expose their APIs, and it is quite good for research, this trend, because we see more things like Open API specification. Open API 3 is available now. So this gives the opportunity, I think, to have better application of GI, because if in your client application you can understand and you can replace API usage easier, then you can potentially improve the non-functional properties. For example, like one of the latest big announcement was from Amazon on Amazon Code Guru, where they are using GI, or they are using mostly machine learning techniques to give code recommendation for performance. On a lot of those performance recommendation that they are giving is about changing the API calls that you are doing in the Amazon AWS. Use this version of the API, use this version of this hash function because it may be more secure, it consumes less energy consumption. Now, taking this, understanding like our work in Darwinian data structure selection was with this basis that, okay, we have data structures that they are having kind of the same interface that are easily replaceable. And our work was focusing on very minimum replaces in the code so you can apply GI. But what we see is that we can extend not only in data structures, but we can extend this to more generic APIs like this. And the first examples that we are trying to do is examples where you are just replacing a library with another library that they have a kind of common API, common interface with minimal replaces. So in this case, if you want to do Java JSON serialization in Java, if you use JSON, usually, there are, if you wanted to go from JSON library, which is a Google, to another one, which is Jackson, which is more open source, and it is another library of JSON led by the open community, you can see that with the minimum changes, your code will compile and will pass the testing. So in this case, we consider this as an API replacement on the code. And only these changes in an application, it can have major performance improvement. So in some experiments that we also did, but we saw also on quite a lot of blogs and research papers, the previous version of Jackson library, it was considered bigger. Also, we always, that's also the power of GI. It's the fact that usually developers, when they write their code and they choose those libraries, we have seen that they choose it based on the generic usage of those libraries. So maybe for the most of the cases, this library is better than the other, or this API is better than the other. But when you're talking about special hardware, special behavior of the application, it doesn't mean that this library or API is better. So we believe that there is a need of transforming and being able to translate APIs with the ability to apply easier GI and improve those non-functional properties. Another example is that we are looking at this code is again the collection API. There are other collections API in Java and other languages, but when we are trying and when we used to replace collections, initially you are quite limited if you want really to apply quick replacement in your code. Initially, you are limited only from the Java collection framework. But if you are looking at other frameworks as well, there you can potentially give better optimizations and you can give better replacements on the collections that you're doing, that you are using, if you use better context. And that context may come from the documentation and the analysis that you are doing. For example, this is an array list in Java definition where you have integers. You can use very easily from another collection. This is just a simple replacement because it inherits and implements the same interface. But if you have more context about the usage of this collection or the usage of this API, if we're talking in general, that this API is only it's not really after the definition, you don't really need to change. Potentially, you can make it immutable, and for the safety property of your program or the behavior of your program, you can give a better replacement of this. Or in this case, which is for integers, you can use another collection that it is specific to primitive type. So this version of the collection, it can be better if you are aiming to optimize memory, So in in our analysis, and when we applied Darwinian data structures in a huge corpus of programs, we saw that that space of replacing different properties in the code, different features that you extract from the code is huge. Like in Google Java format, which is an open source GitHub, we expose 40 data structures. 2 to the 40, it's like huge number. So except for sensitivity analysis and other techniques to eliminate some of those, we believe that if you give better replacement and you understand better the APIs and you have some context on that, then you can potentially have better results.
Michael, you're about 10 minutes in right now, so you're eating into.
Okay, sorry.
Just just to be aware.
Yes. Okay. So so in this paper we are focusing on API replacement, and we are also focusing on API synthesis, where the idea is that sometimes if you have well-defined types and you have well-defined APIs, you have the ability not only to replace APIs, but you can also synthesize code that has the same behavior as an API call. So our proposed framework is called multi-stage API optimization, where we take the API analysis as an input to our optimization platform for better optimization. Okay, I speed it up. Thank you. And something last, so we are very open to collaborating with different researchers. We are doing what Mark said in the beginning, that we have quite a lot of guys with PhDs in scientific research, but we also have an engineering team, and we are trying to combine that by applying GI on those techniques. Yeah. Any questions?
Yeah, maybe one or two very quick questions if anyone's got any. I suppose I'll ask a quick one since I have that privilege. Technically speaking, isn't it rather a difficult problem to swap out different APIs? Don't all conform to the same schema and things like this. Have you found a solution to that problem?
Yes, that is a very difficult problem. Our approach is to start with, like, we want semantically equivalent APIs. Our approach is with starting from kind of bottom up. Start with the simplest transformation that we can do and go up, and then try to define more how an API should look, which will allow you in the future to interchange that. So, for example, on injecting one other library and making simple API changes in the collections API, we have managed to do it, and it's not very, very difficult, because you also don't need to replace the API all over the code. You may just want to use this particular library in a particular part of your code, so you don't break the rest of the code. We are not trying to do full transformation of using one library against the other, but we believe that there are pieces of code that you can potentially import another API that can improve non-functional properties.
Thank you. Okay, I'll do one last question from Bill. Bill Langdon says, can you say more about how you integrate documentation into the fitness?
So that is mostly, so usually the documentation, this is mostly work from my other co-author, Santanu. So forgive me if I don't, if I'm not 100% correct, but the idea is that the documentation, you are using embedding. So you use NLP techniques to provide an embedding of that documentation, and you combine it together with static analysis, so you have better understanding of what your API is doing. So practically, it's kind of when you want to replace an API, you will first look the types, you will look the function definition. But if you want to get more context, potentially you will use the documentation to get a bit. For example, if you can infer from the documentation that this is a thread-safe API, then you can potentially change it with another collection. But better to ask this question to Santanu, and we can have a chat after Bill about this.
Sure. Thank you, Michail. You can stop screen sharing now.
Okay.
Great. Thank you very much. Very interesting talk. Our second talk today will be stack-based GI by Aymeric Blot. Are you here, Aymeric?
Yep, I'm here.
Oh, great. And can you stop screen sharing, Michail?
Yeah, just a minute. I don't.
I think I can probably force you off if you need.
Yeah, let me get out because I cannot. Did I stop the screen sharing?
I think I can maybe kick you off.
Yeah, better like that.
There.
Okay, thank you.
Aymeric, if you can screen share. Great. And please start. And we look forward to see what you've got to present.
Yep. So, hello everyone. I'm Aymeric Blot. I'm with Justyna Petke from University College London. And before I begin, I want to mention Larry Tesler, the inventor of cut, copy, and paste, as he sadly passed away earlier this year. So I don't have that much time for this presentation, so let's get straight to the point. In genetic improvement, you have multiple solution representation. You can deal with the software itself, you can deal with diff patches, but nowadays most of GI work use sequence of edits. The most usual GI edits are deletion, replacement, on insertion. I will introduce a new set of edits with cut, copy, and paste. So the big question is why? So edit sequences are really nice. They focus on the change itself. They are really easy to create, to mutate, and to crossover. For example, uniform crossover, one-point crossover, and they are really close to human understanding. So on the left on the slide, you have a sequence of 2 edits, insert 1, 2, and delete 3. And on the top left, you have a kind of object representation, which is strictly equivalent to the more theoretical list of triplets in the middle, when you have one triplet with I, 1, 2, which represent insertion 4, at location 1 of location 2 of the genetic material from location 2, and D3 nothing, or D3 3. In the work of Oliveira and et al., they introduce a decoupled representation, which is on the bottom left, where instead of having a list of triplets, you have a triplet of lists. So one list for every operator, insertion, deletion, one list for every fault location, 1, 3, and one list for every fixed location, 2, 3, for example. And in that work, they introduce high granularity recombination when you can have crossover that mixed the location between different edits. On another limitation that so that high granularity recombination can be quite complex. On a second limitation that I will mention is what I will call type constraints. So let's have an example of high granularity recombination. So we have 2 individuals. In the left, an edit sequence with 4 edits, so triplets in which all the 3 lists are of size 4. And in the right, an individual with only 2 edits. And we will perform a 1 point across all subspace crossover, which is, for this example, very conveniently cutting the 2 representation between the fault and the fixed sublist. So we cut, we swap, we obtain 2 new individuals, and the issue is all 3 lists are not the same length. So you have incomplete edits that you need to repair. The easiest repair is just to delete those incomplete edits. But in order to preserve the genetic material, the solution that is introduced by Oliver et al. Is to have individual caches for each of the three sublists. So the representation is not 3 sublists for op, fault, and fix, is 6 sublists with 1 cache for each of the 3. Yeah, I think we can do more simple than that. The second thing is type validity. So if you have a GI process that only operates on statements, you will have edits that will look like replaced a statement with another statement. And that's fine, that's okay, it will work. If you have a GI process that focuses on Boolean condition, if something or while something, you will have edit that looks like replace a condition by another condition, and that's fine. But if your GI process can deal with both statement and Boolean condition, as soon as you do eigenvalue recombination, you will necessarily obtain something which will looks like replace a condition by a statement, and that's just wrong. That will not compile and will just have waste an individual. So if you have a GI process that can focus on different types of genetic material, the easiest thing is obviously to do not deal with eigenvalue recombination. That's what happened with the current work that focus on multiple types of genetic material. You can have multiple decoupled subrepresentation. So a part of the representation that deal with statement, a part that deal with condition, are completely disjoint, which means that instead of 2 triplets, you have for the decoupled representation 6 triplets with caches, and 12 with caches, so that's quite complex. And of course, you can devise a crossover that ensure that you do not mix the different types. But yeah, I will propose something else. So the idea is to, instead of having deletion, delete, replace, insert, to have cut, copy, and paste. So let's just take an example. For example, cut 1, copy 2, paste 3, paste 4, copy 5. And let's apply that individual to a software. So we start with no edit and an empty patch, and conveniently an empty stack. And we have cut 1. Cut is just delete with the side effect of adding the argument, its argument on the top of the stack. So if we only apply cut 1, we obtain an equivalent individual which is delete 1 and a stack which contain 1. Now we have copy 2. Copy 2 has no direct impact on the mutated software, but it adding its argument on the top of the stack. Then we have paste 3. Paste 3, which is replace 3, and which takes its second argument from the stack. So you obtain replace 3, 2, and the stack is now stack just 1. And if we apply paste 4, we obtain replace 4, 1. And the last edit is copy 5, which just has no impact because the final stack is discarded. So if original edit sequence cut, copy, paste, paste, copy is just directly equivalent to delete 1, replace 3, 2, replace 4, 1. And it seems that it just works. So first, I just lied. I said that paste was replace. In the original set of edits, you have replace, insert before, and insert after. To be equivalent, you need to have a paste in place, a paste before, and a paste after. Eigenvalue recombination is just a simple non-decoupled crossover, because both fixed location and fault location belongs to different edits. So when you do your uniform crossover or one-point crossover on the list of edits, they are already decoupled. But yeah, it only decouples fault location and fixed location. If you want a full decoupling with also decoupling operators from the 2 locations, you will need something like select or target in addition to copy, cut, and paste. Finally, an idea that comes from the Push programming language is to ensure type validity, you need to consider multiple stacks. So if you have paste with a statement, you will take the second argument from the statement stack. And if you have copy condition, you will push that argument on the top of the condition stack. That just works, I guess. So in conclusion, the idea is to replace the set of edits that we use. It seems that it's strictly equivalent on backward compatible. It offers the same feature, but is kind of simpler. You do not have to have multiple triplets of sublist and caches when you do high granularity recombination, because the memorization mechanism is built in with copy and cut, and it provides automatic type separation when considering multiple stacks. So you can also just throw your GI process to different types of genetic material, and hopefully it will just work. So thank you. If you have any question, I will be very happy to answer them.
Thank you, Amir. Aymeric, if anyone's got any questions, please ask in chat. Okay, one immediately comes in from Wes, saying, could you speculate on the sorts of multi-editing requiring bugs this edit might better support? In theory, both insert and replace and copy and replace could do anything, but in practice, multi-edit repairs are still a big challenge. Difficult question.
Yeah. I think it's a very interesting question. I don't claim that this representation can do better than the previous one. I claim that it is simpler and it provides a built-in memorization mechanism. It can do the high granular recombination, but I'm not sure it can do better or worse than the usual one. It's just, I think, way simpler. The one feature that it actually provides is the automatic type separation.
Okay. Bill asked me, this isn't appearing in a chat because he sent it privately, but is there an advantage of copy, paste, to and from stack that we can operate on much bigger code fragments and lines of code? Yeah,
I'm not sure.
About other like skills like functions or classes or packages or things at a higher level than just a line, basically. And does this stack make it better or easier?
Well, the stack is just the memorization mechanisms to avoid duplicating or having something twice as complex when having the decoupled representation. So, but if the question is for type separation, yes, obviously, I think that if we can target more types of genetic material, then you will be able to do more. The other question is if we generate to edit with the same weight, for example, like deleting a function or replacing a statement, obviously should not have the same weight. But yeah, if it's, I think it can reach more of the search space.
Okay, thank you. I will, this will be the last question because we're kind of just slightly over time. So Shin asks, these two representation schemes are equivalent in their expressiveness, but any change the choice, but any change the choice of representation affects the distance in the genotype space, question mark. So, but is there any chance the choice of representation affects the distance in the genotype space?
So yes, there are some downsides. For example, the edit sequence is now almost twice as large for the same thing. because for each insertion or replacement, you need to have a copy or cut before. If you are worried about distance, you can retranslate it to replace or insert before. One thing in terms of distance that it changes, that if you try simply to generate cut or copy, you might generate a lot of neutral variants, a lot of sequence of the bit that does not change anything to your mutant, but that can easily be fixed by generating simply as before your insertion on or replacement. So generating together your copy and paste instead of only generating your copy first and then generating your replace. That would avoid wasting much space by hoping to generate all the different steps of your replace. You can just generate at once as before, but just use, so it generates the copy and paste together, but then with crossover they are decoupled, so you can have your high-quality recombination.
Okay, thank you very much for that answer. I think that probably answers Chin's question sufficiently. If you can stop screen sharing now, if that's possible. Thank you. So that was a nice technical discussion, and now we're going to look at the what I think of as the other side of software engineering, the human factors. Emily Winter is going to present human factors in the study of automatic software repair. Are you with us, Emily?
Yes, hopefully with all right internet connectivity. Can you hear me?
Yes, I think everything's looking fine on my end, at least. Can you screen share?
Oh, I'm so relieved. Good. Great. I shall share my screen then. Has that worked for everyone?
It's working for me. Yep.
Okay, great. So my name is Emily Winter. I'm a research associate at Lancaster University, and I'm presenting today on human factors in the study of automatic software repair. So this work has been conducted as part of the FIXE project, a research project which aims to establish a new technique to automatically fix software defects by employing machine learning-based defect prediction and using genetic improvement to generate automatic fixes. As a sociologist by background, my role within this project is to consider the human factors within this field. So within software engineering, there has been an increased acknowledgement of the need to study human factors. Software engineering is an activity that is both social and technical. And there has been a subsequent increase in the study of human factors. These have included studies of teamwork and motivation and human values. However, within automatic program repair, there has been a lack of human studies, though there are a small number of them. Drawing on this small number of human studies that do exist, in this presentation, I'm going to present 3 future directions for the study of human factors in automatic program repair. I believe that this is especially important given that automatic program repair promises radical changes to software engineering practices. In addition, there is an often mentioned gap between research advances within industry and what has been considered a slow take-up of these advances in industry. So the first future direction I would like to suggest is moving beyond usability. So when the automatic program repair literature has included a human study, this has usually been done as a way to validate the tool or technique that is being proposed. For example, showing that humans perform a task better when they have access to that particular tool. When studies have included a more attitudinal component, this has often been about how usable developers find the tool. Usability is of course important, but it doesn't necessarily translate to usefulness in a real-world context. For example, the fact that a developer finds an APR tool usable within the context of a controlled experiment doesn't necessarily mean that they would find this same tool useful to conduct their everyday work. In addition, I think the focus on usability can be too narrow, and that there is a need to widen this focus to consider other factors. Like any new tool, automatic program repair tools will displace certain tasks and replace them with new ones. For example, they may replace the need for manual debugging with other tasks, such as choosing between patches, validating patches, and maintaining them. And this may have implications for software developers' workflow, their perceptions of their work life, and even their job satisfaction. So I think it's really important to move beyond usability to consider some of these other themes as well. The second future direction that I would like to suggest is the need for more longitudinal studies. Most human studies that have been conducted within automatic program repair have been at a fixed point in time. And I think more longitudinal studies offer some considerable advantages. For example, we might want to consider software developers' attitudes prior to a tool's introduction, during its early use, and then several months later. This would enable us to achieve a greater understanding of the kind of factors that influence the adoption or not of a tool. More longitudinal studies would also enable researchers and industry to build up longer-term engagement and relationship. And this would enable practitioners to shape the development of automatic program repair and for automatic program repair tools to respond to developers' needs. This opens up a space for greater dialogue between researchers and industry practitioners, rather than developers being more passive providers of feedback. And finally, the third direction I would like to suggest is a greater diversity of research methods. So within automatic program repair, most human studies have used either controlled experiments or surveys. These are very important and useful methods, but like all methods, they have their limitations and should be complemented by a wider range of methods. Specifically here, I'm going to talk about some qualitative methods that I think could be useful. So firstly, ethnographic research would allow consideration of how tools are used in situ, rather than in the artificial conditions of controlled experiments. Being present at a company and conducting observations might also allow insight into how a tool is discussed more informally, for example, at the coffee machine. Secondly, software engineering is a social practice. It involves teamwork and the navigation of team norms, industry conventions, and workplace cultures. I would suggest that focus groups that bring together a team of software engineers to discuss an issue might allow greater insight into how these norms and how workplace culture might affect automatic program repair adoption. And thirdly, design thinking techniques and participatory design could be used to meaningfully engage developers in the design of certain aspects of a tool, for example, its user interface, and to gain their input. Such methods as these are rarely used within software engineering, but they have been used widely and effectively within human-computer interaction. To conclude, I've suggested these three directions to help enable the gathering of richer data around a wider array of topics that might affect automatic program repair adoption. I've also hoped to offer a more software developer-centered view that considers in greater detail how automatic program repair may change and affect software developers' attitudes, feelings, and their workflow. All three of these future directions hope to enable more meaningful engagement between researchers and practitioners, and hopefully contribute to the development of tools that respond to industry needs, which I hope could contribute to closing the perceived gap between advances in automatic program repair research and their take-up in industry. Thank you very much.
Wow, that was perfectly timed. Very impressive.
Oh, good.
I'll stop watch in front of me. That's exactly 7 minutes. So congratulations.
Oh, wow. Gosh, I don't think I've ever done that.
you win the time prize. So I'll open the floor to questions. I see one from Yu Yang. I hope I'm pronouncing that correctly. What are your thoughts on measuring the usefulness of the automatic APR tools to software developers?
Yes, it's I think there's probably lots of ways of doing this. I think like usefulness can be assessed in quite a lot of ways. I think there's possibly opportunities to kind of combine the approach taken by controlled experiments that consider using a tool versus not using a tool, but in a more realistic setting, like within a workplace. I think studies that have been quite successful as well in the past in terms of using that kind of think aloud method, where developers kind of talk the researcher through how they're using a tool, could also be quite a nice way to consider how useful they find it, and particularly maybe barriers to a tool's usefulness. So those are some things that I think could work well. I think also considering like how we what kind of things we measure when we measure usefulness as well is interesting. I think it gets used quite a lot in quite a broad way, but whether we mean saving time, saving effort, reducing certain tasks, I think maybe thinking a little bit more about kind of what usefulness actually is for developers as well, and how they would define a useful tool as a starting point as well.
Okay, thank you very much for the answer. So Wes has a comment here. He says, you're a right to hold our feet to the fire about this, Emily, but the pragmatics are tricky. For in situ ethnographic studies, we've seen that companies are wary about sharing or publishing their data. Even in Mark's great keynote earlier, he couldn't go into precise details. Are there any best practices from the ethnographic side, e.g., we promise to elide this detail as soon as it is written down, that would make it easier for companies to agree to these techniques?
Yeah, that's such a great question. I rather optimistically admitted the challenges that are included in this paper, in this presentation. But yeah, it's a major challenge, I think. Something that I have done in the past with industry is kind of draw up a very basic partnership agreement that lays out kind of expectations from both sides as to what that relationship looks like. Obviously, it's like it had to be a company that was kind of interested in doing that kind of thing. So that's not necessarily a kind of a solution for every company, I guess. But I would say like properly sort of setting out that from the offset is definitely something that I think would be really beneficial. And I think being like really open about those kind of ethical considerations as well. I think that often in research, like usually kind of submitting our ethics forms to our ethics boards, and it's quite a tick box kind of process, but I think to be sort of constantly sort of negotiating and navigating those kind of ethical considerations as a kind of constant process, like throughout the research relationship as well, is something that I think could be useful, and perhaps like we don't do enough of, I think. So I think that could help. Something else maybe as well, sorry, this is quite a long answer, but something I've found quite helpful in the past is we sort of adopted a kind of, because I think one of the issues with ethnography, as well as some of these ethical considerations and privacy considerations, is the time that this takes for industry, the sort of time commitment. And so we actually sort of drew up a kind of agile style time frame that involved some research sprints. So it kind of felt like we were speaking industry's language a little bit more on that. But yeah, those are just some initial thoughts on that. But yeah, a lot of thinking still to do on it.
Thank you. I'm going to take the two questions here, and then I'll wrap up. So Myra Cohen asks, aside from the usefulness, is there a notion of trust that may be considered?
Yeah, definitely. I think trust is a really important thing. There's definitely been some research that does show that developers prefer patches that look more similar to human written patches, for example. So definitely exploring that trust element, whether developers would have faith in a tool for certain types of fix and not others, is something I definitely want to think about more.
Yeah, that's really interesting. On the kind of human-looking patches really help. I've always thought that myself. Eric Schultz asked a question that I think is actually kind of very in line with the question I wanted to ask. Presuming limited development is a hurdle to some of these larger studies, could we learn from similar studies on other software automation techniques which are more widely deployed, e.g. simple software bots on GitHub, or linters, which could be seen as mini APR?
Yes, definitely. And actually in the paper, I talk a little bit about automated testing, where there have been a few more qualitative interview-based studies as well, in comparison to the automatic program repair literature. So I definitely think kind of drawing on some of those other fields is important. Yeah.
Okay. Thank you. I think you've got garnered a lot of interest there, so you can take the rest of the discussion offline. I'm sure you're easily contactable.
Yeah, thanks everyone for some excellent questions. That was really interesting. Thank you.
If you could stop your screen share and I'll to the next one. Okay, so our next talk is Towards Guided GI with Oliver Krauss. Oliver, are you here?
Hi, yeah, I'm here, and I hope you can see my screen.
Oh, wow. You're screening.
Oh, what's happened there?
Oh, that's it. This is interesting. Okay, let's, yeah, please go ahead. Please start your presentation.
Okay, hi. So hi, I'm Oliver, and I'm presenting towards knowledge-guided genetic improvement. So what is this about? This is basically about combining grammar-guided genetic programming and tree-based genetic programming into knowledge-guided genetic improvement. And if you're wondering right now, how does it get from programming to improvement? So this technique is mostly useful for non-functional feature optimization, which is also the reason why it's more useful for genetic improvement. So as a short introduction, and give me a second, I'm just going to move the control panel. So as a short introduction, grammar-guided genetic programming is basically just genetic programming using a grammar to create syntactically correct individuals. This was originally done only for the crossover operator, but now has been extended to most operators. So tree genetic programming is utilizing tree structures, very often abstract syntax trees, to basically achieve the same goal, to enable new operators, for example, a homologous crossover, which basically enables you to move a subtree into a different part of another tree, but keeping the context around it very similar, so it doesn't immediately break if it's moved. Previously, this has been combined into tree adjunct grammar-guided genetic programming already. And so what we are proposing with this paper is basically moving one step further. So if you already have an abstract syntax tree representation, and if you have your grammar, you can then enrich that grammar with metadata. And you can also implement operators that can utilize this metadata and also access the context your abstract syntax tree is being generated in. So by context, I really mean you can access the stack and the heap to also determine if variables were initialized and so on. So this slide is basically what I'm talking about. And it's the concept is you have a root operator that basically just points to all concepts in a grammar or in a language. So this would mean literal values. This would mean, for example, an if or a while loop. And basically every single concept in here then has information, relationships to other nodes that says, okay, if I have an if condition, you have to put specific sub nodes in there so it's syntactically valid. That's just basic grammar-guided genetic programming. So how this operator graph is extending this concept, you can see here in these boxes, which is basically you add metadata to that. So for example, what's the minimum size I can generate in different concepts? Or what is the McCabe complexity of the code that's coming out? So none, or is it branching, or is it a loop? And then we are getting to the non-functional features. So for example, what is the expected runtime of these nodes, which you can only measure without compile optimizations, obviously, but you can still measure it for specific concepts. You can also measure, for example, are these allocating memory and how much memory is allocated, and so on. And how this concept in itself works then is when you generate a new syntax tree, for example, for a mutation, or you just want to select one for crossover, you tell the root operator, this is my context where I want to generate the syntax tree. And you have to keep to these guidelines that I'm giving you. So for example, you can actually tell it, okay, the runtime of the subtree must be at most 100, and it will generate only what is valid in this context. So the proposed impact of that is, obviously, we hope to increase the amount of valid abstract syntax trees. And those will not just be syntactically correct, like it would be in grammar-guided genetic programming, but will also be semantically executable. So it might not be semantically correct, of course. It might not do what you want it to do, but it will definitely execute without any runtime errors. And what this should enable as well is more complex operators and approximation functions in the fitness. So instead of, for example, measuring the runtime, you could just use this metadata to approximate it and say, okay, we just generate our runs faster. This syntax graph can also be modified. So this is just a real graph with edges, and you can just move or remove those edges to, for example, say, okay, we get a lot of endless loops, and these endless loops happen because the condition allowed to use, let's say, constants, so while true. And you just remove this edge and say, okay, you can do everything but constants, and you immediately have more valid syntax trees generated. There's obviously some drawbacks to this approach as well. So for one, the metadata mining is very complex to just get all of the information that you want to utilize. And it's expensive in the sense that you have to mine every single concept in your language because you have to have all the metadata and not just parts of it. So for test language, this, especially for the runtime measurement, it takes a few hours to days. Obviously, these complex operators also cost you in runtime performance, but that's generally true for any operator you would use in genetic improvements that just does more than random search. So also, if you make a mistake in your syntax graph, and by that I mean if you remove an edge that you did not intend to remove, you might endanger the validity of your experiment just because you just removed something from a search space that you actually did need. So as a conclusion, this is very useful genetic improvement, as I said before, because most of this is for the non-functional features, and this is useful in that case. The approach does show promise. We are already at 100% compilable abstract syntax trees, and we are at very high executable abstract syntax trees, and I do not want to put the number there until my empirical evaluation is finished. We are getting higher all the time though, because we are constantly improving the current graph that we're using for test languages. And what we also want to answer in that empirical evaluation is how much will the overall quality in individuals improve over the whole run? And does it increase the success chances of experiments? So can I actually do more complex experiments that will optimize more complex algorithms? And with that, I'm happy to answer your questions. And you should see down here as well, there's the link to the paper if you want to read it. And this is part of my PhD thesis, so I will be happy to answer questions or collaborate by email as well.
Okay, thank you very much. Again, another perfectly timed presentation, so thank you for that. Has anyone got any questions for this? I'll give it a few seconds. I suppose I'll just jump in with one that I've got. You're keeping your cards quite close to your chest about the work you're doing now. But one thing I wanted to kind of get a kind of handle on slightly, if you're willing to reveal some information, is like, what's your target like application size and what are you optimizing for right now using this approach? Like,
so what I'm optimizing for is currently pretty much exclusively runtime performance. Mm-hmm. And I have it a little bit easier than you would expect because I'm using the Truffle interpreter and the GRAL compiler in the background, which actually lets me touch the compiler level of the code I'm optimizing and also look at what is the stack and the heap at this current moment. So putting the context into the graph, for example, for me is incredibly easy. And it might not be as easy if you would use it in another approach. And I think I have to ask you again for the first part of the question.
I was wondering like the size of the applications you're currently working on to get a grasp. Are you still like small programs or kind of real world applications?
It's currently only small programs. In the sense of real world applications, yes, but only dedicated algorithms. For example, we are currently doing a study on sorting algorithms. Where we want to optimize both the runtime and the energy performance as well.
Oh, cool. So that answered my question sufficiently. We've got two questions in the chat. One from Eric Schulte. This static limiting of mutations sounds very promising. Could you give examples of how you mine, e.g. runtime metadata?
Okay, yeah. So the runtime mining is a little bit cheating, because for runtime mining, you actually have to disable all compile optimizations. And the reason for that is the approach of how we mine the runtime. So basically, for each concept, there is an implementation behind it that is just one class in Java or Truffle. And so we generate one node of, for example, the int literal and duplicate it 10,000 times, and then run that. I think we run it 200,000 times, the whole program basically, and then say, okay, the average of those 100,000 runs divided by 10,000 is this runtime value we're giving it here. And then we move through all of these features. So for example, in the if, you definitely need sub values, and we just basically remove what was executed with these literals again from that. But we did have 10,000 ifs run, so it gives us a pretty good approximation. But because we duplicate and cannot pull out the values in every single instance for different nodes in this concept, you have to disable that the compiler removes the unused code.
Okay, thank you very much. There's only one more question. Maybe you could take this offline, but Wes is asking, are you on the job market right now?
I think I'll contact Wes directly.
Yes, I think that's something better to offline. Okay, does anyone, I'll give just literally like 10 seconds if anyone's currently typing anything right now. Otherwise, I'll take the opportunity to move on. Okay, I think you're good if you could just close your share screen. And thank you very much for the presentation. Oh, Bill, I think we'll take Bill's question offline. You can maybe answer it in the chat. But Bill's got asking where the grammar is from. So our next presentation, Aymeric is back with synthetic benchmarks for GI. Aymeric, you're still around? Yep, you still got. I have to apologize, people. Aymeric computer appears to censor some of the presentation, but it should be. I think it's tolerable. Okay, Aymeric, I guess you can go and begin.
Sure. So I'm still Aymeric Blot with Justyna Petke from University College London, and this time I will talk about synthetic benchmark for genetic improvement. So in a nutshell, there are many things I want to do with GI. I want to do empirical comparison of GI approaches. Which local source should I use, or which GP source should I use for GI? I want to do parameter configuration of GI. I want to automatically know if I should use a small population for GP, a medium population, a large population, or if it depends on the target software I am evolving. If I want to dream big, I want to be able to do genetic improvement of GI, so to have a GI process on top of a GI process on top of the software I am evolving. And in general, I really want to be able to do quick experimentation for GID. I want to be able to have an ID, implement it, and have a quick feel on if it's worth it or if it will work or not, and not wait months of comparison between the original or the state of the art and my epsilon ID. So the idea is that GI, when you apply it on software, is very slow. But this is mainly due to fitness evaluation, because the software itself is slow. So the proposition is to replace the software by a synthetic model that you obtain beforehand. So issues with real-world benchmark. So as I said, evaluation range from slightly expensive to extremely expensive. Second thing is good data is scarce. We don't have many benchmark for GI. And I think one of the reasons is that we don't have that many projects, that many software that we can use, that we can say, hey, just run GI on that software because we know that there are easy fixes on that they have that specific feature. For example, if I have an ID for GI for epistasis, if are my edits independent or not, or are there only single edits or multi-edit improvements? I'm not really sure, even if I consider previous GI work. Possible solution for that. So when your evaluation is too expensive, you can use surrogate modeling. So basically, you start your GI process with your software, you evaluate it, you evaluate it, you evaluate it, and at some point, you stop evaluating it and you start guessing what fitness value are based on the previous evaluations. You can have artificial instances when you have small but good data and you want to have more. For example, if you are running a software, you are improving, let's say, minisat on some particular set instances, but you do not have that many because they are expensive to get and expensive to evaluate. You can generate more instances which preserve your structure. What I will try to say is that GI might need a synthetic benchmarks, so completely artificial benchmarks that are obtained using real-world software, but that are very cheap to evaluate. So a bit of formalism. GI is kind of usual optimization problem when you have your original software from which you derive your search space on all the software variants you can get. And from that search space, what you want to find is the one software variant that optimizes some statistical population parameter over some cost metric over some input distribution. But let's say, for example, it's you want to optimize the average running time of minisat over some instances, or you want to optimize the total energy consumption of running your software on a particular machine. That's the first line of the formalism. And the idea is, even if only the cost metric is expensive, if you have to run to evaluate your software on many test cases or many instances, then what was already expensive become way more expensive. On the more software variants you want to investigate, the more expensive it becomes. So in the particular thing that I will describe, I will just want to replace basically everything by a model which is instantaneous. Basically a single query. I generate a variant and I can instantly say it's good or it's bad. So let's look at the search space we want to model. So in the left, in the middle, you have S0, which is your original software. And around it is all the edits you can apply to it. And for each step, all the edits you can apply to your modified software. And at each step, you have around n deletions. If you have n location you can work with in your software, around n square replacement, n square insertion. So if you want to consider to modelize sequence of edit up to say k, you basically have to model n to the power of 2k values. And that, yeah, slightly too big. However, if you make a single small assumption that edits are independent, or that fitness values can be obtained considering edit independently, we can reduce that to only n square fitness values. And that's way more reasonable. So in practice, what do I propose to obtain that synthetic model? Basically is doing empirical analysis on real world software to take your original software to sample edits and to collect data. For each edit, did the software variant compile? Did it run or did it crash? Was the final answer correct? and how much did it, how much better or worse was it? For example, in runtime, in energy consumption, or whatever your cost metric is. And from that empirical analysis, compute the underlying distribution so that we can just draw from the distribution instead of evaluating your mutated software. To get from that distribution to your sequence of edit, you basically need to aggregate your contributions. So the rules I propose are to propagate compilation error, runtime error, or wrong outputs. Meaning, if you have a sequence of 10 edits on one of them did not compile, we just assume that the whole sequence did not compile. Duplicate edits are ignored. So if you have one very good edit that cut your runtime into 2, if you consider it 10 times, it still only cut your runtime into 2. And that other fitness ratios are multiplied. So if you have one edit which makes your software faster, one edit which does not have any impact on the running time, on one which is slightly slower, you still want to have something which is faster. So in conclusion, if you apply GI on some real-world software, it's a process which is much slower than running your software. If you want to apply GI on top of GI on top of software, it's a process which is much, much slower than running GI on your software. So the idea is replace software which is slow by a model which is very cheap. And so that when you apply GI with your model, which you obtain something very quickly. So that, for example, if you want to apply GI on your model, then it becomes reasonable. So the advantage is it enables to build cheap and reusable benchmarks. So if you want to try any ID or any prototype of a new GI process, you can just run it on your synthetic data before, if it works, running it on your real-world software. The models that you use are as complex as you want to design them. So the one I propose here is really, really simple. But if you have any features that you want to modelize, if you want, for example, to modelize epistasis or neutral variance, you just have to include it in your model. And it will still be cheap, and it will provide other GI practitioners with a model which is designed with that particular feature in mind, instead of, I don't know, having considering previous GI work and say, I'm not sure if there is epistasis there, but let's check my epistasis GI process on that, so that you can focus on your ID rather than just reproducing results or guessing if that feature is included in your software. And that's it for me. Thank you.
Thank you very much for that interesting presentation. If anyone's got any questions, as always, please put something in the chat. Oh, Bill Langdon is asking, can the synthetic benchmarks be used in a non-GI context? E.g., could it be used in one of the meta-heuristic optimization competitions, something run by the CEC or other conferences?
Well, I think GI is at the combination of software engineering and optimization. On their side of GI, which are simply tied to optimization. So when considering models, you just remove the hard part on expensive part, which is software engineering, to only focus on your landscape, on the feature of your landscape, so that it becomes a really only a optimization problem rather than a software engineering plus optimization problem. So it would be in the context, for example, of CEC or Gecko, to propose a new optimization problem, which will modelize the hard real-world software engineering problems. So yes. So basically removing the GI part to any evolutionary algorithms that will work on the landscape, which is so when we consider when you apply GI. I hope that answers the question.
Yeah. Anyone else got any questions? Nope. I suppose, have you had any, like, have you, I always thought I'd just take advantage of the fact that it's actually a long time since you emitted this paper and presenting it. Between that time, have you implemented this idea in the real world in any way?
It's funny you ask that because I did that for the other paper, but not this one.
Oh,
I checked if a prototype was possible. So in practice, how to actually model it so it can be very cheap, easy to write, easy to get results. But the one thing which is hidden in the slides is you need to do the empirical analysis. So you need really to sample a lot of edits from your software for it to work. I only checked if it was possible to, in practice, do it, but no, I didn't do the empirical analysis yet.
Okay, well, I look forward to your paper next year where you tell us about how this all went. Bill is making more of a comment, I suppose, saying that we could reuse the work in the triangle problem, the triangle program. I think, like, for something like this, you probably really want to start as small as that, I assume. Modeling complex things is hard.
Yeah, then the question is the triangle program really representative of the landscape we actually use for GI? Or how different will it be if we sample actual landscape rather than the landscape for the triangle program that you exhaustively investigate? So I'm not sure if the triangle program is really representative, but yes, that's the idea.
Yeah, I think the insight Bill's trying to, or at least well, okay, maybe I'm projecting here, but for work like this, you really got to start, I think, small and prove it works at least at a small level, and if it doesn't, and then build up to something that's more representative. Like, we talk a lot in GI about whether these programs are representative of X code, but I think there's so many different domains of software. There's tiny little applications all the way up to Facebook level apps, and you know, I think if you can get it running the triangle problem, that will be a big step forward in this sort of research.
Yeah.
Again, more of a comment than a question.
Yeah, I think one thing which is important is as soon as you have your distribution, as soon as you have your model, you can generate a lot of benchmarks that are very similar to that model, but not really equivalent. That would allow to compare your GI process on more than one software. As long as you can generate landscapes that are true enough, then you can try your GI process on many different landscapes that looks real and that have that particular feature that you want it to have. But if you really restrain to exactly model something that exists, then you lose that opportunity to have many different but slightly similar benchmarks.
Okay. Anyone got any last minute questions? If not, we'll move on to the discussion section. Nope, Bill just saying that you raised a good point. Okay, thank you, Aymeric. You can stop sharing your screen. And yeah, Justyna, were you chairing the discussion section? I almost forgot what our schedule was here.
Wes, and then I will take over if Wes needs to leave.
Okay.
Excellent. Okay. So if I'm interpreting the clock correctly, there was so much discussion during this that this is the kind of the end of the time we'd set in the original schedule. So if there are, one or two people who may have to disappear, we quite understand. But I hope, we'll beg your indulgence, I hope you'll stick around for a little bit more of the discussion. We'll be waiting here longer. And I'll re-mention something we said at the beginning, which was that last time the discussion was so fruitful, we took some notes, did some follow-up. It ended up being published and involving the participants, and that's not necessary, but if that's something people are interested in, it's definitely something we can do. I want to just set this stage with a few possibilities for things we could cover in the discussion section and then turn it over to all of you. So I'll mention that follow-ons to paper presentations or questions are entirely fair game. I think there was a question Eric had for Emily about limited deployments and software bots on GitHub that we might not have had a chance to address. I think Bill asked one of Oliver that might have been answered in chat. But if you had another question for one of the papers that we didn't, or one of the presenters that we didn't quite get to, now is a great time to ask it. I do also think there were some cross-cutting themes that we saw, even with just a small number of presentations. I might pull out something like social good or broader impact, broadly construed in both Mark and Emily's presentation. I think this is a place where we might talk a bit about resource sharing. I don't want to put anyone on the spot, but I think there are at least two companies represented in the audience, perhaps Facebook and Grammatech. And we heard some mentions before of either approaches like a partnership agreement. I might be curious to know if companies would accept those or what would have to be done. Or we heard some new techniques like a stack-based GI, and I might wonder, is there an easy way to try out a new technique like that on a industrially deployed tool like SafeFix? We could talk about that sort of thing. And then we often conclude a bit or hear from people about what we as a community see collectively as the big open problems, things we'd like to see solved or things that were brought to our attention by the workshop. And I'll just mention that one of the big advantages of a workshop like this over a conference is the social interaction, the sharing of ideas, especially ideas that might not be perfectly finished. So I'd like to encourage you, especially if you perhaps haven't had the chance to speak up next. By no means are we expecting perfection. We'd like to hear from as many different people as possible. So with that, I will stop talking and turn it over to you. And then if you either use the raise hand on the right, or if there are comments in the chat. And I think perhaps Bobby or others can help me out with this. In the discussion section, it may be possible to unmute people if they want to just speak verbally. That might be a bit easier.
Everyone has the power to unmute themselves. So I think if I'm wrong, then please ping me, but I think that's the case. So yes, just unmute yourself.
Excellent. Yeah, and sometimes it's easier to say something verbally than it is to get it down precisely in writing. So what are our thoughts?
So I'll say something, Wes. This is Myra. I think that benchmarking and having sets of exemplar programs that we can use and the community can work with is always a really positive thing. It pushes the research forward. It helps us work on realistic questions, which realistic within the range of what realistic means. But I think there are a lot of opportunities there, and if there was some way for us to build those artifacts as a group and to make that available, I think it would be great, or to have our industry partners help us with that. I mean, because in other words, if we do this as researchers, we will build things that are not realistic, that don't represent the real world, and it would be nice to have some input or guidance, with what those would look like.
Interpreting that broadly, if there are people here representing industrial companies, if you're willing to speak up a bit, totally non-binding, not speaking for your company, but you've likely seen a number of the benchmarks we use in the community, either especially on the program repair side. There are a number of C or Java instances out there, often taken from open source, and I'd be curious to hear your thoughts on whether you think those are indicative or the dimensions that we should be pushing in, or even what it would take, special kind of licensing or whatnot, if there were some way we could use even extracts of your code. Are there people here from industry who might be willing to speak up to address the last point?
Yeah, actually, I would like to say some points that I have observed from the conversations that with different kind of other people from the industry. It's that, first of all, I wanted to mention the social impact. Like, when you're talking about GI and everything that's automated to make their code better, coders are a bit scared, say that, many times they say, so you are going to replace me, you can write better code than me. So you have to go with the approach like, no, we can automate some parts, but this is for making your code better. So I think the GI as a code review, integrated into code review processes and services, that because also of the limitations that a lot of GI approaches don't rely on test cases. So it may not be really representative of the performance of an actual application. Then as a code review where you say, okay, you know, part of this continuous integration, you have a GI process that will be running on a benchmark that represent that behavior of that application would be very useful. And it can expose GI much more into the wider industry. And the other important aspect would be the if GI it comes with what Mark was saying, and mostly with A/B testing as well. It's how we can build GI in a scalable way that we can. For example, if you have an application and you want to run this genetic improvement over different generations, can you deploy automatically 10 versions from a population, have the users interact, get the fitness, and then suggest the other one? So the deployment and the integration with the existing system, it's very, very critical to have wider applicability. That's what I have felt. And also most of the real world systems are very complex and they have a lot of dependencies. So applying it on even open source projects which have some tests or small benchmark, it shows, it's like, okay, good to have tool, but I think it needs a lot of work, and mostly it may be engineering work and frameworks so we can integrate them in the real systems, which can bring real value to industrial partners and businesses. And yeah, and that's in our startup what we are trying to, one of the problems that we have addressed, and it will take a lot of time to address it, and maybe big technology companies can address this because they have the resources, but smaller companies or more traditional, it will take a lot of time for them to get GI inside and automation. And I think if GI research community shows more real use cases and do kind of more advertisement in this area, it will have much more applicability. Because if you think about, you know, the trend, the hype that machine learning has taken and artificial intelligence, which is kind of automation, and most of the time the problem in the industry is about automating stuff. It is very well advertised and integrated in existing system, even though currently the adoption of machine learning in most institutions in London is like 10% or something. Still, it's a very big thing, and a lot of money are put in that. So that's my I don't know. Correct me if I'm wrong, but that's my my opinion on this market so far.
Personally, my I suppose the hurdle that I think isn't kind of discussed. People say that we want to do more with industry and work on more real world systems. But the question is always, well, what do we give industry exactly? Because I don't think, I might be wrong on this, I might be offending some people when I say this, but I don't think there is many kind of off-the-shelf downloadable tools people can plug into their systems and see them run. And then if it's not that, you're talking about having an intern in your company for a few months building the system for you, and that's a risk, and that's something else to have to handle. I've always thought if maybe want to get this sort of research started, a good starting point would be, why don't we give some students or some people to build like a Jenkins plugin that builds off some very basic GI principles, and basically see if anyone wants to incorporate it into their continuous integration systems already. I do think the lack of, because the feedback from industry I've seen in GI seems to be mostly positive, but there's just not enough of it right now to garner any big conclusions. I would definitely like to see more tooling, because if someone's interested in putting GI in their processes right now, I'm not sure what we hand them over. I would like to say, download this and plug this into your backend, and this will do it. You can tell us how you feel about it.
Adding to what Bobby says, and I know Bobby's research and I have read, I think for wider industry adoption is tackle problems that have money. Like if you go and say you have a plugin or something and you say, okay, this application that is running on your cloud and it's running on 1 million machines, you can improve energy consumption by 5% because in this open source application that you have, I show that, and that converts to money for them, then you have a win. Then you have the buy-in from those companies. Unfortunately or fortunately, the industry is very money-oriented most of the time. So, but if you can really solve the problem, then I think you tools will be and GI will be much more adopted.
Eric, it looks like your hand may be up virtually.
Yeah, I guess I'll pick that up. I do think that's maybe one distinguisher from industry is more of a reliance on CI systems and sort of formal merge review processes. So I definitely agree with the point that integrating into these systems like GitHub and GitLab is a big opportunity to make it easier, to make our tools sort of directly applicable. The Repairinator project does this, sponsored by the Eclipse Foundation. So there is some work there. Unfortunately, that only applies to Java, so that's one limitation. Yeah, I guess that's all I have to say. In terms of representing industry, I don't know that Grammatech counts. I think we're about 3 orders of magnitude at least smaller than Facebook. But yeah, there's certainly open source software that's as complex as what you're going to find in a company. You know, like Wireshark has millions of lines of code, and you'll get equally convoluted build systems, I think, in and out of industry if you look hard enough. So yeah, I feel like processes is maybe where there's a bigger systematic difference.
Since you're speaking, if you're willing to have us put you on the spot, do you think a company like Grammatech, maybe one that's a little smaller than Facebook, would be amenable to this sort of in situ ethnography, following developers around and taking notes that we heard from some earlier presentations, or would that be a harder sell?
I think it's a harder sell in the same way that like we don't have money to do internal research and development. We're sort of, you know, smaller and on tighter margins. I'm certainly trying to dog food the tools that we're building internally, but even internally, I'm doing that more on the research developers, where we sort of have some coercive abilities as opposed to the product developers. So yeah, I certainly can't speak for, probably even for Grammatech, but certainly for other small industries. It's difficult.
Yeah, so you have to find the spots that you will do the engineering as well as you will be evolving the research. And that is a constrained resource problem that needs optimization as well. So, but it's a bit more dynamic. So probably we need to use more reinforcement learning, these kind of things to model it. But I think it's a very good opportunity for people in the GI space to further push the research and to make it a bit more public. Maybe we should call it more on the AI if we want the wider like the AI for code is very a lot of companies that have got a lot of funding and are doing especially in US are using it. So and if you go on the techniques, probably they are more genetic improvement and this kind of thing. So that's my feeling. Yeah.
Follow up for Mike and question for Mike and Eric. Like, what would be more useful? Kind of an Eclipse plugin that says "bam, run GI" and then you can see what it does, or whether it would be useful to maybe for the company even to give us some code and then we'll just show you like within 3 commands, you know, you're running GI on your code, and then what would be the bigger grab, I guess? Like what, I don't know. Like in what I'm just trying to narrow down what's the, because you mentioned plugins, so maybe do you think that's the best route, Mike?
Sorry.
So,
yeah, Eric, maybe.
Yeah, so So we use GitLab internally, and I think many companies use GitLab because it's easy to run it on premises. So a plugin for GitLab that, say hooked into the CI process and maybe suggested fixes when a test failed in CI, something like that would be probably the easiest because there's no friction on developers. It's just providing, maybe suggesting merge requests that they can ignore if they want to. And you could also probably fairly tightly control what information flows out of the company. So like our product side would never give anyone their source code. It's like not going to happen under any sort of agreement. But if you can be very specific about the metrics you're collecting and then how you're sort of aggregating those and sending those out, I think there'd be a lot more openness to collaboration.
Yeah, code, it's very difficult for systems. So there are two things here. One is the companies don't want to give the code outside, so they would like your tool to be inside, but also you don't want your tool, especially if it is, you have the code or you haven't packaged it well, to be taken by the company and not have the dependency. So it's a bit, but I see it more like a cloud service nowadays, because on the GitLab, Git, or all these, with Jenkins and so all these continuous integration processes, because it's better if it is kind of independent process. And if we make those tools as part of the continuous integration and part of their code review, then that is they will be adopted over time, because it like in the beginning, I guess Facebook and those companies started very strict code review processes, and a lot of people were pissed off in the beginning because probably they said it slowed down the release, but over time they will help. That's my feeling. Now on the plugin side, I think also that could be like nowadays there are a lot of cross plugins for different, Visual Studio Code, Sublime, Eclipse. So if you can have this kind of plugins that are more universal, that can give, I believe, users can start using it more.
Thank you.
Looks like Emily has a hand up in the official system.
Yes, I just had a question for Eric, actually, which was about kind of researcher access to companies, and I was wondering whether the barriers that you were identifying were more about kind of privacy, about kind of what was being developed and that kind of thing, or whether it was more of a resource constraint that like having a researcher there wanting to talk to people is just like too much time for the company to take out, essentially. Or is it both of those?
I think it's more the latter. It's more just about losing time.
Yeah. Interesting. Cool, thanks. Yeah. Also, just in relation to one of the comments that we've just had on the chat, which is about kind of programs becoming hard to understand for humans, and so I think that's like quite a big question there around like kind of how for example, like the results of an automatic program repair tool are like presented to developers, and kind of what that looks like so that these tools are acceptable and trustworthy for developers as well. So just more of a comment there, but yeah.
Just in case not everyone listening can see the chat, Xiangmin Li, my apologies for the pronunciation, asks, would easy applicability solve the problem towards the industry? The result of GI could often make the program hard to understand for humans. So if the program development is still being developed, developers might not want to use some tool that would break up their program, even though it passes all the tests and gains efficiency. So this challenge of the human acceptability of either patches or improvements remains a big one. It may be if he's still here, or is willing to chime in to some degree. Facebook deployments seem like at least one example where that's been addressed positively on a large scale, where humans are manifestly willing to use the tools, but it may be that there are many of us here who could speak to that point.
I don't know if I'm going to be able to that. What I would say is this is a fear, but in practice, there are several examples of GI in use where people take the code and used it and built it into their existing systems.
Bill, I regret it. It may be just me, but you're sufficiently difficult to hear in terms of the audio that it might actually be easier if you could either write it down and I could read it out, or maybe if you muted your camera, we could hear your voice. Were other people able to hear Bill? He was shall we say, a little scratchy.
Yeah, it was scratchy. Yeah.
And it looks like Bill may be writing that down. A note in the chat from Eric about plugin development, giving a particular pointer. Bill says, developers have taken onboard GI code and included it in GitHub and developed on top of it. It can be done. And I'll just echo that from various RepairNator projects or RepairBot that we've heard earlier. There have definitely been instances of people being willing to accept more human readable patches or improvements. I might challenge the rest of you, though. I think there may be folk wisdom that sometimes the best benefits from GI come from when it generates the most alien looking solutions, when it's least like a human. So are there ways to get those accepted by developers?
I don't know if Mark is still here, but I was kind of interested in like how Facebook had developed the tool that they use and kind of what kind of interaction they'd had with their developers to kind of enable its acceptance. And I don't know whether anyone has any thoughts on kind of the difference between kind of in-house tools and something that's kind of brought in from like more externally.
Yeah, Mark's not here, but the one thing I do remember him mentioning is that at first they focused on just one type of bugs, which is the null pointer exception, and just apply like very simple mutations, very simple templates. So I guess the advice would be start simple. And then, you know, see how it goes. But yeah, I can comment more on that.
At the risk of channeling the discussion a bit, we have another question in the group chat, never mind. Maybe this can be another point of view about what I said. Maybe I don't have to make an understandable program. While machine learning also makes things hard to understand, it is still used because the models can be used in a standalone way. Could we use GI in a standalone way or something? That is an interesting challenge for us. On a personal note, I might note that there's a lot of pushback towards explainable machine learning and AI recently. That the story might not be as one-sided in terms of its deployment, but the notion of a standalone GI is compelling. Eric Frederick asks, could this be a good segue into bringing the topic of explainability into GI?
I wanted to add that if, for example, one case is that we were working with a potential industrial partner on, we are using genetic programming to generate machine learning models in our platform. So the first requirement was explainable AI, as you say. So they didn't want us to generate models automatically that are very complex. So that was one of the requirements. So things like deep learning or very complex trees, or they want to replicate because they want to understand, because there are a lot of industries that they need to validate the decision, which comes with ethical machine learning and everything like that. The other part was when you select this model, if you're using genetic programming approaches, then you have also to validate that you selected this process using a process that they can validate, that if they run the same optimization process, that it will come to the same model selected or model tuned. So yes, I see in the industry this is very, very important, which is reproducibility and explainability of the GI process, at least them to be able to reproduce. And I guess this comes together with the reproducibility of experiments that are done and how you can have random seeds on your optimization process so you can replicate or at least explain. So yes, I think this is very interesting, very interesting topic, while GI and machine learning is adopted more in the market, because there are these kind of cases that you take a decision, the machine learning takes a decision that maybe a client didn't like it, the client goes and complains, and then they cannot explain why you take this decision. And there may arise a lot of issues, like sometimes it can be social decisions, depending on the background and these kind of things. But the person that is using the program doesn't really know in that case. So that's why we have this kind of requirements.
A virtual hand. Mira, are you turning on your...
yes, my virtual
yes,
hand.
Please,
so I think explainability is almost built into GI and search, and we don't utilize it the way we could, because we spend a lot of time exploring different spaces. We're searching large spaces, but we're learning a lot about at least the positive cases, because we're sort of looking at a biased part of the search space. We're guiding our searches towards whatever fitness we're using, but we learn a lot along the way as we do that. And I think we could very easily use that information to provide explainability. And I think it's almost built into GI, and we can do a lot more about it. And maybe that's what this group should end up with at the end of this conversation, is how we build that. Because I think it would be an interesting position to take, that this whole community, that we have this as part of our community, and it can really help sell the GI and have people believe in these techniques, because we know what we're searching. We have information, we have traces, we understand what parts of the space we've looked at, which edits we've thrown out, which ones we've kept. We have fitnesses along the way. So I think we have a built-in way to do explainability. We just have to be able to package it in a way that can be used. I'd be curious what other people think. That's just my opinion, obviously. Are you talking, Wesley? You were muted.
Are we in a broad agreement over what would be explained? One of the more direct bits might be, should you accept this patch or this delta that would improve your program? But the more we hear discussions about things like, oh, we know which parts of the search space we've explored, it may be that part of what we want to explain is this represents a good best effort search. You're unlikely to find something better by hand because we have been looking in so many places. We also heard, or there was a point in the chat, maybe we need to consider mutation operators that are designed for semantic explainability. I don't want to say that's in opposition to the comment we last heard, but on the one hand, we've heard suggestions that we already have a rich amount of information we could use for explainability. And the other is maybe it's more of a research problem to design for explainability. What do we want to explain, and how do we think we'll get there?
So I agree with that comment about syntactic mutation. I think if you build your GI in a way that you can provide more useful information, it would definitely help. So my argument wasn't that everything's immediately there, but I think we have a process and a search that builds it in, and adding information that would be useful would be an interesting way to go.
So just adding on what Wes said about, well, actually both you, Myra and Wes, about which kind of region of search space looks promising, which doesn't. So that's one thing. So that's kind of narrows down the regions of code where mutations are likely or less likely to lead to some sort of improvement. But the second type of information it's going to provide with the patch is more about how that patch affects the control flow within the program, those sort of stuff. Again, this is something that we can currently do. It's just not packaged yet, I guess. That's the question, is what other information would be useful.
Is explainability separable from the problem of overfitting? The more we start trying to explain why this is a good patch, the more we're tempted to go back into some of those. Well, I ran it on all of your test cases, or maybe I made some new ones. Here's why I think it will generalize to be successful in follow-on situations. Are these the same problem wearing different hats, or are there aspects that only come up in explainability that don't come up in overfitting and patch quality?
I don't know, maybe one could help the other, as in if you can explain what's happening, we can figure out whether it's actually overfitting or not. Don't know.
It's a great question, I think. I think in general, we tend, and this is why I was thinking we needed more benchmarks and more input from industry, because I think we tend to come up with a few small examples and use them over and over. And that builds a little bit into sort of fitting, but explainability really only tells you that specific problem. So explainability isn't trying to explain all of the space. It's trying to say, during this particular genetic improvement, here's what I learned, here's what I tried, and here's why I made this decision. So I think explainability may have some difference from the overfitting, but it's a definite risk. And so I think we have to consider that.
There's a comment from Shin suggesting that he sees explainability as somehow related to Occam's razor. It should be minimally explainable, but this might potentially form a tension with overfitting. On a more general note, I've heard comments from us favoring realistic benchmarks, industrial deployment, and explainability. I might ask if these are the big challenges we observe. In previous years, things like scalability or repair quality might have made this list. So I might wonder, is it the assessment of the community that those are perhaps less pressing problems or were addressed in the past, and that these notions like realistic benchmarks, deployment, and explainability are more central now? See a comment from Bill. Explain, the ML people have a sidestep. Explain is taken as justify. We did X because X is similar for another customer or data point. Bobby quotes in a question from M. Wagner on the live stream. Overinterpreting local optima is a great thing. Otherwise, one just looks at points somewhere in the middle. Of course, this is a bit different, very slightly, for automated program repair versus genetic improvement. And David Clark argues that explanation is a psychological problem. We had some mentions or discussions of trust and human factors earlier.
So I'll maybe push back a little bit on seeing need for industry cooperation as a roadblock. I think there are sufficient and sufficiently mature open source projects that are doing their development completely in the open and are willing to accept patches from anyone, that there's no real reason not to be, aside from scalability probably, and the engineering work required to integrate, not to be applying our techniques directly to those projects and see if the patches are accepted. And that gives you a natural metric for this is a poorly explained patch or poorly motivated.
Okay, so just kind of quick follow-up. Then which projects would you recommend? What features the projects would have to have? Just coming back to benchmarking, because honestly, we've been having this kind of discussions over and over again about benchmarking. It's kind of, I don't know, hard to gauge.
I'll ask because it's a really good question. I don't have an answer. The ones I can think of are more C and C++, but that's a miserable set of languages to work with because the C preprocessor can do such violence and you have to make your changes before the preprocessor.
Yeah.
Yeah, probably you could look at the NPM ecosystem for JavaScript. It has a couple nice properties. It's sort of uniform how you run your tests. It's easy to parse and there's good language support for some of these things. And it's heavily represented on GitHub, so you can easily find what are important projects.
Okay. Thanks.
More comments in the chat. Eric Frederick notes, I think scalability is a continuing problem, especially in data-driven or big data types of applications that are becoming more and more common. Seems quite believable. Bobby reports to us, M. Wagner from the live stream, benchmarks, this is a big problem in other communities too, even in traditional optimization.
Well, I guess it depends what you mean by scalability. I think we have tools that can be applied on large software bases. I guess it's just a matter of run time involved in those applications. I don't know. It's my feeling.
Right. Let me pick on my own work, especially since there's much better stuff out there. But an outdated view of scalability in GI might be that in as much as we succeed at applying to larger programs, it's because of a combination of high quality fault localization. Even if the program is large, we restrict attention to just a few lines, limited operators or fixed localization, and then getting lucky with some sort of improvement or repair that's really just one or two edits. And this could well be me being behind the scenes, perhaps, or behind the times, perhaps other people would want to chime in, but I'm less aware, maybe outside of Facebook, of deployments to really, really large programs where any of those assumptions is violated, where it's harder to tell which part of the program you should be changing, where you need multiple dependent edits made at the same time. And I know from Angelix to Hercules or whatnot, people are struggling with this problem, but I feel like in that regard, scalability may still be a challenge. But don't take my word for it. Indeed, I'd love to hear that I'm wrong.
I feel like, well, I might be stating the obvious, but that's kind of the advantage of those maybe silly single mutations that they do, like the heuristic based approaches that do apply to large software, even though they're somewhat not as sophisticated, which, for example, Angelix and Semfix do. But then on the other hand, those tools have a harder time to scale. So it's like maybe you need some sort of hybrid of both.
Are there other points either on this topic or returning to any of the previous papers or other themes that people would like to revisit or mention now? Scroll and see if there are any.
I suppose one thing I wanted to jump in with at the end was more of a meta question. So I'm going to make a guess, a pessimistic guess here, that, well, we know the next GI workshop, the 9th, is going to be virtual. I think probably likely the 10th is going to be virtual. I'm not predicting things going to be cleaned up in 12 months' time. So my meta question is, how does this virtual setup work for you? Is there any improvements we can make? I would also say longer term, even if when this all does get cleared up, personally, I would like to see a virtual option or a virtual component in future workshops. I think it's very democratic. It allows people who maybe can't attend conferences to attend in some capacity. And there's obviously going to be a line there. People do still want to meet up in person. I'm just wondering if anyone has any comments or suggestions or things that went well, things that went badly. I suppose let's make it as broad as that.
Even just broadly to expand on that, there may be 20 people who are attending, but perhaps we didn't hear from as directly. In theory, under participants for Zoom, there's like a raise hand, yes, no. If I could trouble you, especially if you haven't spoken, do you think this went well? Were you able to hear the presentations? Do you feel like you could have asked a question even if you chose not to? If you could just answer, click a yes or no, we can kind of scan it to the right, and you don't have to say anything out loud. But this might give us some, we will not be looking at your names. No is a fine answer, but if you maybe don't want to speak out loud, just click a yes or no under participants in the chat. There's some icons there next to a hand. And then by no means do I want to cut off any qualitative responses to Bobby's question. Bill seems to be asking about time zones. might not be interpreting his question correctly, but that's definitely a challenge if we're trying to get America, Europe, and East Asia all at the same time.
Yeah, this is, like, to put it in perspective for the, like, this is 6 a.m. start for Californians and what, a 10 p.m. start for Koreans. And that's, I think, honestly, the best we can possibly do with time zones. I mean, the Pacific Islanders are probably even more annoyed if there's any one of those in any of them in here. Yeah, you can't really change the geography of the planet. We had, I ran a different workshop. We had 2 sessions, one that was more European American centric and one that was more European Asian centric. And I didn't really ask for feedback on that, but we did have slightly demographics for each of the 2 workshop sessions. So we made sure authors were divided up between that as well. We also made recordings of the presentations and the workshop, so anyone who couldn't attend one could watch the other. That's also another solution.
So I was part of Deep Test, which ran 2 sessions, one for one more familiar, convenient for Europe, and then one more convenient for US. And the practicalities of it is you will attend 1 session probably. So and then the promise is that, you know, the other session will be recorded so you can revisit, but that's not going to happen in very short time frames. So you may have to allow, you know, some period of time for people to actually catch up. But then obviously this sort of breaks the discussion side of workshops. It may actually be better for conferences where the focus is on the presentation, so it's a bit more one way, but the point of having this is to have the whole sort of community discussion, and then that becomes actually a bit harder. I mean, within each session, I think it went down very well. For workshops of size up to 50 people, I think Zoom is handling it very well, and then, you know, you can ask questions to anything that you want to do, but synchronizing different time zones is probably the biggest problem.
Maybe I'll ask, I mean, I was going to say, so SBST had a more shorter, like, presentation session and then longer discussion session. Maybe that's, well, we can still do that sort of 2-hour thing where it's, well, inconvenient, but maybe not run over, and then shorten that, and so that everyone can participate. Because I feel like, yeah, I mean, I agree with Shin, like, for conferences that I work, but for workshops where this, like, the discussion, the interaction is more important. I know, maybe the SBST way was the better way.
That's a good point. I think SBST was the only one that tried really a very different and new what's the word, format. My brain is shutting down. And yeah, that may actually work better. So for those who were not there, what SBST did was the talks were just pre-recorded videos, and then they were uploaded a bit earlier than the actual event. So people were actually invited to watch them in advance, and then the actual workshop was just discussion session. So they only did the interactive bit in real time for everyone. So that's another way to go. Yeah, I actually liked it. I thought it might be just too, you know, it can be awkward radio silence if people are not really participating. But okay, the keynote was live, and then there was the discussion session, and I think it went down pretty well.
They had a pub quiz, which I liked. It's pretty fun.
Who won, by the way? I didn't hear the result.
Is Eric here?
Yes, I am here.
Yeah, I don't want to say.
Justyna ended up winning.
Okay, great.
Yeah.
Oh, no, it was Phil. Yeah, that's also true. I think the chairs did a lot of work, so that's maybe the downside.
Yeah.
And Oliver points out the ICSE workshops appear to be all over the place in terms of time zones. I'd also like to point out that this is a holiday basically in the US. The 4th of July is on a Saturday. I would find it very weird to schedule stuff for the 3rd of July for the American audience, but I guess, yeah. So maybe we could have had more attendees, but I don't know. Yeah.
Seems like, I just want to say, it seems like, well, it's mostly us organizers talking. I want to hear something more from the participants.
Yeah.
So the holiday actually helped us here because we have fewer regular meetings, so we can take more time off. Some people aren't at work that can watch that may not be able to, so that was actually a lucky thing that happened today. I see there's a comment about Australia, and right now that's the one part of the world we've really put into a bad position because they have to be up in the middle of the night. But I think when I fly to a conference, my time zones change and I show up for a talk, which is 2 o'clock in the morning for me. So I think if people really want to attend, as long as we move things around and give them a chance, so not everybody's always getting the benefit, I think it would work.
I think the one nice thing, at least we saw at SBST, was we had more participants virtually than we ever have in person. So I think at least some kind of a hybrid approach in the future is definitely, it's probably not a bad idea for people who can't physically attend.
I'll admit, I'll be curious to see how that pattern continues when it's not ICSE giving you 4 free workshops for the price of 1.
That's a good point.
But I remain quite optimistic.
I think you guys ran it quite well. I enjoyed it, so good job as well.
Thanks.
So on positive notes, if the discussion is winding down, I think it's possible. Justyna may have 1 or 2 conclusion slides.
Oh yeah, I do. I forgot that. Should share my screen. Okay. Okay, so I hope everyone can see my screen without any issues. So basically, this is just a quick closing from like all of us who organized this workshop. We would like to thank our PC, who did a great job at doing great and timely reviews. Again, another thank you for Gavin for making changes to the website, for you for tweeting the event, for also spamming all sorts of mailing lists and people doing lots of advertising on our part. Also thank Mark for giving our keynote. And most importantly, we would like to thank you for sticking around, for attending, for submitting papers, and we hope you enjoyed it. Hope if you're especially a first-time comer, you also check us out later on and the other GI events. So here's just a recap of what's coming up, and but all of this information is actually on the Genetic Improvement of Software website. So if you just go there, you'll get pointers. By the way, the tutorial that's at ASC is also going to be given at Gecko, but anyway, there's just lots of GI around. So I hope you enjoyed it, and I hope you enjoy, well, also attend future events. So thank you again.
And there was a last minute request. I'm not sure if we can actually pull this off, but just in case, in the past, we've had pictures of participants. If you feel comfortable doing so, would you be willing to turn on your camera just for a minute? And then Huang Yu, who's handling social aspects, can take a screenshot, you know, for the website, that kind of thing. No requirement for this at all, especially since we did not mention it in advance.
So Wes, while they're doing this, is there some sort of opportunity for people interested in following on, as sometimes you do with a workshop, or just curious from the organizers, or we can just end here, but I thought I would open that up.
That is a great question. I feel like normally I lean on Bill pretty hard for that. Bill, if there were interest, is there a way we could send around, or I don't want to put extra work in your plate, but perhaps we could send an email to everyone and then say, oh, if you're interested, reply here. If there's some Slack channel or something like that. Is there a way if people had follow-ons? Oh, wait, and of course, I just asked Bill, who we've established can't speak out loud because of, all right, well, that is a good point. We'll look into one.
Yeah. Okay. I would just say email us, you know, as for Bill as well. And yeah, we'll stay in touch. I don't know if anything might come up with discussion. We did have the benchmark issue, the explainability issue, and the industrial adoption issue. I hope that these were the three main points that were being discussed. So I don't know if another maybe short follow-up might come out of it. We'll probably send you an email and we'll see yeah, how that goes. Yeah, and feel free to email us.
And I'll just take a quick, I guess, screenshot of this Zoom screen. So over the next 5 seconds, if you could all look presentable, and no promises it'll be on the website if it doesn't look good, but let's see.
Did you catch Gabin?
Yeah, there's gonna be 1 more second. Okay, we're good.
Cool, thank you, Bobby.
See how that looked.
Thank you all.
Yeah, and yeah, thanks everyone for sticking along, especially Shin. Who's had a long week.
Not just me. Apparently, Marcus, he's 1 hour even ahead of me. So
oh,
him on the YouTube live stream.
Yeah.
Okay.
Thanks, Marcus.
Yeah. Okay. I'll stop the recording now.
Right.